Okay, I've started streaming. Excellent. That worked. I don't know why this works so well. You'd think it would be more complicated. Let me check if anybody else has showed up. Oh, two people are. Who are the two people? Oh, excellent. All right. I got Rock Howard and Isiah.
Cool.
Okay. Uh, yeah, sorry, I let you guys sit in the waiting room. I was mucking about with YouTube. We are streaming live now. And we are looking very, very dapper and well groomed, I must say. Uh, or not. I have my Soft Kitty T-shirt on, and that's pretty much my formal attire. So how you guys been?
Pretty good.
Okay, so for those who don't know, we have Rock Howard. Well, that's his name. So and Isiah and Sam Lichtenstein. Sam is a veteran of the old Unseen podcast, so you guys probably some people will know him. Um, the Unseen podcast ended almost 2 years ago. So
But you still have the back catalog, you know,
I put it on all on YouTube.
getting literally dozens of views probably.
Well, it does get a few views, but I don't really check them that often.
Uh-huh.
I figure, well, okay, it's there if anybody wants to has some sentimental reason they want to go visit it. But as far as I know, it'll be on YouTube forever. Um,
Until the robotic overlords who run Google decide for whatever reason to take
yeah,
it.
Google decides, hey, you know, anything over 5 years, we're going to kill it. You know, which you get what you pay for. But I was paying $15 a month, or so $6 a month, just to keep it on Libsyn, and I let it go for a while because I wanted people to have a chance to download any episodes they wanted, and it got thousands of downloads. And I said, okay,
Is it $6 or $16?
$6 a month.
Sure.
That's $72 a
Not
year.
bad, yeah.
Yeah, and then when you. So anyway, I I said, well, you know what? I really just don't want to pay that. You know, every once in a while, my wife makes me cut expenses.
Yeah. Yeah.
She'll
Yeah, I
say,
mean, it may not be worth it, but
yeah.
it seems like a fair price actually, because I think
Oh, it is.
that
I
probably
I think Libsyn is
justifies
very.
the host,
Yeah.
just the hosting cost for the files, right? Because it's
Yeah.
probably, I don't know, couple
Yeah.
dozen gigabytes of audio files, something like that.
They'll
So
store any size number of files you want.
without charging you more, if you have like thousands of episodes, they must
Yeah,
charge you.
it doesn't matter to them. I
Really?
mean, they're so big that it's nothing.
Huh.
You know,
'Cause I would've
you got terabytes of episodes. That's to them. That's nothing. Um,
I would have thought the file hosting was like the main marginal cost for them.
no.
to keep it
What
up.
they do, where they limit you is on the monthly uploads,
Oh,
depending on how much you pay. But I was well within that.
Mhm.
Even when we were doing one every week, I still had no problem fitting inside the bandwidth. I could just make this because you can make MP3 files smaller
yeah.
just by cutting the bit rate a little bit.
Do you guys
And
ever listen to the space show? This
I don't know it. The podcast.
Yeah, it's a podcast. Some guy out in California.
I think I used to listen to him. Then he had Hoagland on, and I canceled him.
Anyways, like setting aside the content, one thing I admire about the guy is that he keeps the MP3 files at about 10 megabytes per episode, which is, very. A lot of people they use too high fidelity audio, but some people obviously feel very strongly that you want all the you don't want to drop any bits from the file, but I can't really tell a
yeah,
quality.
it really most people. I mean, you can't hear the difference between 96 kilobits and 128.
Mm-hmm.
If you play music a lot on your podcast, then you probably want a little bit of higher bit rate. But if it's just incidental music, nobody's going to care.
Although I guess actually I do always liked the DJ Spooky thing that you play. Like that's
Yeah. Oh, I actually wanted to ask, who is that guy?
Say again.
Who's DJ
Who is
Spooky?
DJ Spooky?
Hold on a second. I'm not probably suddenly having. It might be my old
Oh,
age, but having trouble hearing. Okay, there we go.
You want
Turned
to
it up
know
a
who
little bit.
DJ Spooky is? The guy who did the music for your podcast.
Oh yeah. Well, I actually have always wanted to do just a music podcast. I would love to do that, but I just don't have the time, and I don't have the rights to play most of the music I want to play. So I'd have to go like buy an ASCAP license or something, which, now we're talking money.
So, but what's the answer to Isaiah's question? Who is DJ Spooky? Like,
I'm really having trouble understanding. I think
who is DJ Spooky?
Oh, DJ Spooky? Oh, well, he's this. He started out kind of like a hip hop guy, but he branched off into jazz and other stuff. And he's very.
Is he local or something?
He's New York. His real name is Paul Miller. And he's got some real like hip hop albums out from his earlier days, but it got weirder and weirder. So it's like weird hip hop.
Uh-huh.
Oh, Rock Howard came back. Hold on. We dropped out. You're back, Rock.
Hopefully his connection's better.
Sorry, I didn't notice you dropped out, but I was trying to fix my audio. But anyway, hold on, that reminds me. So anyway, yeah, DJ Spooky is he's done some albums I really like, and some that I'm not so keen on, but and he's a pretty cool guy. He likes to work with really top drawer musicians and just let them create, and then he builds things around it. It's kind of like a hip hop Brian Eno. If you're familiar with Brian Eno,
produces other records.
Say again?
He'll produce albums for other artists.
Not so much that he'll like remix or mix in his own beats and stuff to what other people are doing, or he'll just it's a collaboration. If you listen to Brian Eno's really early records, which are wonderful, he basically said, I'm not a musician, which is not really strictly true. He is kind of a musician, but he would bring in really excellent players and get them to play really, really well. And
what's your favorite Eno album? I'm a fan of Another Green World.
Another Green World is excellent. I like Taking Tiger Mountain a lot.
Yeah, that's good. I'm not so into the ambient stuff.
Well, I do like the ambient stuff.
Music for Airports. You like that?
Which one?
Music for Airports, I guess, is the most famous.
That's okay.
Yeah.
But I like the Fripp and Eno especially, because I think Fripp is the greatest master of looping that there is, and he kind of learned that technique from Eno on that album. And
anyways, getting back to more typical fare, what's new in Space World with you guys? Anything exciting? I've been kind of distracted with non-space stuff recently. But.
Well, only thing I've been following is my own work, which is JWST. I don't have to do anything.
Can you talk about it or not really?
I can talk about it, but I can't, air the dirty laundry, but things are going well, basically. And I think it's public knowledge that they are waiting for Arianespace to finish another launch, and they're going to evaluate that. And that should be sometime in the next few weeks.
Paul, I wonder if you have a loose cable. I'm hearing feedback that sounds like it's coming from your end.
Sounds like ground loop.
No, I don't.
Yeah, there's a lot of buzzing.
Is there?
Like ground loop, or is that a loose cable?
Because I have a. No, that shouldn't be a ground loop.
Actually, it sounds a little bit like a distorted echo.
Do you have an iPhone?
No, I'm going into a Shure SM7. me and through a very well grounded connector into
But Paul, if you switch your headphone input to whatever's coming through the stream, I think you'll hear what we're hearing.
Or I guess we could be getting feedback from one of us.
I tried muting myself. I don't think it's me, but
Well, though, what it's better now. Oh, let's try Paul. Paul, go ahead.
check.
still bad.
Check.
Feel bad. Let me
Really?
mute
Really?
let me mute myself and see.
Paul, say something.
You're still hear it? You're still hear it? It's like an echo, is it? It's like an echo, is it?
Yeah, and the delay is getting longer and longer. It sounds like.
Code cancellation problem.
No, I don't understand that. I don't understand that. I'm not.
It actually sounds really cool, but
Hold
We
on.
can
Hold on.
get DJ Spooky on the line.
yeah.
Let me
Okay,
go
muting.
look at my.
I'm muting myself.
Look at
Didn't
my.
make a
Okay.
difference.
Here, well, let me mute my. Here, I'll mute myself. I'll mute myself. Can you hear me now?
We can talk amongst ourselves.
Can you hear
That's
me
how it
now?
works out.
I don't know Jim's. I don't know Jim's Sky, but I'll let him introduce himself.
I didn't catch any of that.
New
Hello, Jim. Hello, Jim. I guess we don't know you. You want to introduce yourself? Introduce yourself.
Hello.
Hello.
Okay.
Hello.
Hi there.
Hi, Jim.
We can hear you.
Hey.
All
We
right.
can hear you.
Let me turn this off here. Yeah.
Okay, you guys talk. I'm gonna go see. Okay, you guys talk. I'm gonna go see if my cable's connecting. All right. It should be. It should be.
Okay, let's see. Well, I'm Rock Howard. I've been on these things a few times, and I'm a kind of an ex-computer programmer for about 40 years. I got my degree in physics and astronomy at Caltech when I was a youngster, and did a lot of fun stuff as an amateur astronomer. I helped run a planetarium, and did a lot of astronomy activities. Discovered a star. So I got a lot of little astronomy stories, and I'm also a big science fiction fan from the golden age and so forth. And so I know a little bit about that, and I still follow astronomy and to a lesser degree, space oriented stuff, really closely. So I'm pretty up to speed on what's going on in a lot of these areas. So that's me.
I'm Sam. I'm less up to speed, but I sort of have a background in math, and I work in sort of computer stuff these days in the financial industry.
Hi, I'm Isiah, automation engineer, and I just like space stuff. And I got to work on Curiosity for a little bit, so that was kind of cool.
Cool.
Yeah, a really, really, really small part of it. I do put it on my resume because why shouldn't I? But
Right.
I
assume that was at JPL. So are you out in Pasadena area or?
No, I live in New Jersey. This actually was in Buffalo, New York, of all places, during my internship in the university. Weird little fact, like 5 out of the 6 pressure sensors in the world are made in the Buffalo, New York metropolitan area.
Huh.
Just the way it is, I guess. And I worked at one, and we
Sorry. I'm sorry. My dog is barking. She's got to go out, so I'll be right back. But I'm sorry I interrupted you.
So I got to do my internship at one of those companies, and the power supply on the pressure sensor that was used for measuring the atmosphere of Mars, I got to spec it out a little bit and test it a little bit. That's my entire contribution to the Curiosity probe. But
better than most people.
yeah, I learned a lot.
Well,
I just it was really cool internship.
Actually, I turned down a job from
you've got to.
JPL back in the day. I was gonna. They wanted me to help the team that was pointing the cameras for the Voyager missions, and the pay was horrible, and the
They didn't
project
include-
didn't look to me like it would go anywhere. And
Hour-
Lockheed
the-
offered
The hours were
offered
probably
me.
bad too, right? Because you got to talk to the probe, whatever.
No, this was like you're
supposed to,
setting
right?
up these picture runs like months in advance
Oh,
of
I
when
see, I
the
see.
spacecraft shows up there. So that wasn't a problem. But Lockheed offered me about 3 times as much money to do computer graphics. So I went there and
Uh-huh.
became a programmer.
Yeah, I followed the money myself a couple times. I can't blame you.
Paul, your audio is much better now.
But,
I don't know what you did, but it worked.
I didn't. Well, I went back and checked the cable, and I thought it was plugged in solid, but
Makes a big
maybe it
difference.
just needed some encouragement.
Oh, I gotta ask. Sorry.
Yeah, go ahead.
I mentioned in the group chat the thing with Solaris. I'm really curious. Rock Hard, as a sci-fi guy, did you see the connection, or was it just me imagining it?
Well, I guess I didn't quite get it. I read that book so long ago, and I haven't really seen the movies. Was this from the movies or from
The book,
the book?
yeah, it's really is a tomb, but the real summary is that humans meet an alien that's so alien that we can't really do anything with it.
Right.
So at one point, out of desperation, the humans hook up an EEG. The thing responds to gamma radiation, so they make this little gamma ray generator, and they hook it up to an EEG, and they shoot it at it, and they're like, well, okay, maybe he can understand us. The other way around. That was kind of like to summarize that part of the book, and I was just like,
I didn't. Yeah, I don't know that one, so I'll have to ask Daniela about that. Maybe she was inspired by it.
Well,
She's,
okay. Well,
but
can you describe her latest project a little bit better? Because maybe that's the part I didn't really get. It's like,
I don't fully understand it yet.
okay,
I'm gonna. She's on vacation right now, but when she gets back, which I'll be on vacation next week too. So sometime in late August, we'll have a chat about her project.
okay,
And
that sounds like fun.
I'll get better informed on it. But my understanding was that it was actually beaming a signal back to the Earth that was supposed to look something like an alien beacon. And it's an art project. It's not meant to make any scientific point. Just like her, her beaming EEGs into space was.
So that
Quantito,
sounds like it. That sounds like it might run afoul of some of the. I don't know if these laws are actually in effect and policed properly, but there are some laws against beaming stuff back to Earth for advertising purposes, because there were proposed launches to put like big advertising signs up in Earth orbit, and so there had been, I think, an international agreement not to allow that.
I'm sure she
This
would.
sounds.
She
like
would
this-
probably reject the premise that advertising and art are close enough for there to be overlap, right? I mean,
question.
right, unless someone wants to make the point that you're advertising the artist or something, but it's still, it's kind of borderline. It's kind
Yeah.
of interesting.
Well, this was a radio signal, so.
Right. That's not
Yeah,
quite as bad.
and-
what's it being
And
bounced
an
off
understanding is the
moon?
transmitter was fully licensed and all that was not, it was on frequencies that were approved. So
if
it's
the
not like-
idea, yeah, you could claim it's scientific by just saying, well, this is going to allow us to test our various SETI installations to see if they can actually.
I don't think
this
that
up
was
is
the
what-
point. Yeah.
Right, but they might want to
it's
make
never
that
been-
point.
Well, maybe, but
What's the signal
You know,
bounced off of to get it back to Earth?
Moon, right?
I think you just transmit it from a satellite.
I see. Okay.
But I'm gonna have to look into that more depth. I don't understand. I have really just skimmed the articles that she posted
There was a big
because I got so
brouhaha
much other
just a
stuff
few.
going on.
There was a big brouhaha just a few days ago because there was a headline that some
SpaceX.
outfit was going to do a quote advertising in space deal.
Yeah, and that was
from
that was
Elon.
not a. Yeah, they're gonna launch on a as a co-passenger on a Starlink launch, and it's a
Right.
tiny. Apparently, it's a CubeSat, and it's not
Mhm.
doing anything obnoxious. It's just transmitting something.
Well, it's doing like a selfie stick to take a picture of a digital display with the Earth in the background.
It was
Right.
cool.
So it's not beaming stuff down from orbit, which the headline of the article made it sound like they were going to put a big billboard in space. And so a lot of astronomers got very up in arms about that. But that's not what's going on at all. But what was interesting to me is I remember that Planetary Resources almost a decade ago did some kind of Kickstarter to do almost the identical concept. I think the Kickstarter got funded, but I don't think they ever actually delivered on the capability. Does that ring any bells?
There was an Asimov story that I remember from a long time ago, in which some aliens come to Earth and they want to buy Jupiter.
Oh,
And
I know what you're talking about.
and so they bought Jupiter, and nobody knew what they wanted it for, and they put a massive billboard on it.
That's funny.
It was fine. I'd be cool with it.
Asimov frequently did kind of goofy, funny stories.
Yep.
But yeah, I think that actually it was an anthology of stories that I bought from the Science Fiction Book Club, probably in the mid '70s, and the
I
name
was
of
a
the
member of
anthology
that.
was by Jupiter. I
I
had
was
a
a
pile
member
of
of
those
that
things.
too. Yeah.
Yeah, I remember when I was in my 20s, I had this massive pile of science fiction books that I knew I wasn't going to read again, so I took them to the bookstore, and they were ostensibly hardbound, but they were what they called trade paper, and the
Right.
bookstore wouldn't offer me very much for them. They gave me like $15 for the whole box. And I said, "Fine, take them. They're off my hands," you know. But
I have a rather extensive collection right now and thinking about starting to unload them finally. But turns out people
Yeah,
don't read
well-
books so very much anymore. So
I don't know. I have a bunch, but they're all just sitting on my Kindle, and so they have no resale potential whatsoever. You know.
right.
yeah, well, I like paper books, but we have limited space for them, so I have to every year I have to go through and prioritize the ones I want to keep. And
I think I've got the entire Philip K. Dick collection, for example,
Nice.
and a lot of Golden Age stuff. So I have the entire Foundation trilogy, and there's actually like 9 books in that series now,
there's a bunch of Foundation books, yeah.
plus most of the robots as well. So
Are you planning to watch the Foundation?
There's also a Robots and Foundation book, yeah.
There's
I
the
don't
Foundation is supposed to be a
eventually
TV show
title it
soon,
together.
right?
I don't know how they can
On
make
Apple TV.
that novel series into any kind of TV or cinema. It just doesn't make sense to me because in a real sense, nothing happens in those books.
That's what makes Philip K. Dick adoption so well. Like, because
Stuff's going on. Yeah.
he always puts in at least one action scene in every novel he writes, no matter how, or short story, no matter how boring it seems, he always puts one in. That's why, I that's my theory, at least, why he's been adopted more than any other writer.
Well, also he's just a very good
There's always
world
one car
crafter.
chase,
He's so good at creating worlds that he doesn't mind destroying them and putting a new one in its place at will, just willy-nilly. And so that makes it pretty exciting stuff.
Uh,
You know,
I
well,
forgot. I forgot. I think it was you actually, Paul Carr. The one book you recommended on the show. I read it and I can't remember where. I know it was from a podcast. I read this book and it posed an interesting question: who's the real hero of 2001: A Space Odyssey? And I thought the answer was interesting.
it's Hal, obviously.
No, well, that's something that's not according to this author. It's not the real hero. Who's the real hero? I guess
The baby?
the satellite that you only has mentioned in one paragraph. The satellite.
I don't remember. Satellite.
When they uncovered the monolith on the moon,
Okay, sure.
it broadcast a widespread spectrum and just as loud as a high magnitude. They had a radio astronomy satellite far out past Lagrange spot, and because of that, it was far enough that it was able to figure out where the signal went, and it went to Jupiter. So therefore, they could have the whole mission to Jupiter. So the satellite's the hero of 2001: Space Odyssey.
I like it. I've seen that movie well over 50 times.
That's
Mostly
a case
in
where the movie is much better than the book, in my opinion.
The movie has so much space that every time I watch it, my mind goes in a different direction and I think of new things. For me, it's like almost like an unfinished painting where every time I look at it, I can see it going a different direction. And so I've found that movie to be extremely rewarding.
I would
Of
say
course,
that Stanley Kubrick is a better director than Arthur C. Clarke is a writer. I'm going to go out on a limb and say that.
Oh yeah, I would say that too. But I will say that they were better together because some of the things that Kubrick wanted to do, Clarke had to talk him down out of the tree, and that seemed to be that worked out.
So does a monolith count as a probe?
I would say so.
Yeah, it's
Who counted? Oh, there's Ciro. Well, before we go any further, Nick and Ciro have just showed up. Hello,
Cool.
Nick.
Hello. Greetings
Ciro's.
from rural Clatsop County, Oregon.
Are you having
just
still
got
having a
back.
heat wave out there?
Yeah, well, we had a couple days ago, we actually had 92 degrees, which is very unusual because it's very close to the coast from here. And then when it was 92 in Brownsmead, it's 102 in Portland. It's usually 10 degrees warmer if you go inland. And then it's 10 degrees cooler if you're right on the coast at Astoria. So I had just gotten back from taking a short swim in the Columbia, and I was driving back here and I realized, oh wow, this is the wild pod signal evening.
Yeah, the pub. We are going to do a WoW Signal live soon, I hope. Yeah, that will actually be like a focused episode, but I can't make any promises yet because
if you guys are all aware,
the guest has not agreed.
Nick has a weekly newsletter which you can all subscribe to, and the most recent edition had some great complaining about Portland in it.
It's become a thing with me because a lot of people here I'm not in Portland right now, but I'm often in Portland, and a lot of people there are in very deep denial about the catastrophic state of the city.
Catastrophic. I guess I'm not well informed. What's the?
Last year we
falling apart?
last year we had a year's worth of rioting, and so a lot of the buildings downtown are still boarded up, and everything is tagged with graffiti. And so when you tell people that, and they say, "Oh, it's just a few blocks downtown," no, it's not just a few blocks downtown. In a misguided sense of I don't know what to call it, the homeless camps have been allowed to flourish, and there's immense homeless camps, which means people having campfires outside when it's tinder dry and 100 degrees. So that means fires and burned out husks of cars and places that used to be perfectly safe that people don't go to anymore. And the city is, and as I also wrote in my newsletter, last night. You know, even if all the physical damage is repaired to the city, it's still, there's a black cloud of anger and resentment that hangs over it, and it's not like it was before, unfortunately. Portland used to be a very laid back place, and people, you know, that's why we had the Portlandia TV series, and everybody thought it was funny in the last 10 years when a bunch of hipsters were moving, but now it's so changed the politics into something that's almost grotesque, and nothing can get done in Portland anymore. But I was praising in my newsletter, I was praising by comparison Vancouver, Washington, which is right across the river, not to be confused with Vancouver, BC. So just on the other side of the Columbia River, there's a small town in Washington called Vancouver, Washington. But that town has come through relatively unscathed. They've upgraded their waterfront. They made a really nice park. There's no people shooting up in Publix. There's no immense homeless camps. And it's become a pretty nice place. And I pointed out that people in Portland used to make fun of Vancouver, but now it's a lot nicer place than Portland.
Well, as a New Yorker, I should speak up for, you know, people shooting up in public is what lends character to a city. It makes it, keeps it interesting.
Well, then you might like Portland.
Yeah. Going back to an earlier topic, Paul, before you had the audio issues, I think you were going to give us a brief update on the JWST stuff that you were working on. To the extent
I think it's all pretty public now. I mean, my impression from working on the program for about a year and a half, is things are going pretty well. The observatory, this is an incredibly complex observatory. All kinds of things could go wrong. And if any of those things go wrong, you're going to have a compromised or even lost mission. But there's been enormous amounts of work done to try to beat down all the risks that are known. Because what they're trying to do here is just really, really, it's a virtuoso performance, and you only get one chance to go out on stage and perform it. And
so I should know this, but it's supposed to go at Earth Sun Lagrange point. Is that?
Yeah, Earth Sun L2. And
so it's too hard
which
to.
is
we can't
actually
send
a great place to locate a telescope.
But it's too far to send a Dragon capsule if we need to have astronauts fix it if it's broken.
Well, I mean, I suppose you could figure it out eventually how to service it. But right now there's no plan to service it. No.
That could be a new contract for Bezos. So,
yeah.
Well.
So Paul, in retrospect, I mean, obviously the decision to park it at L2 makes it fairly singular. But in retrospect, just in hindsight, do you think that large missions like this with so much risk are better served by having the budget to go ahead and build 2 of them or even 3 of them just to help ameliorate the risk? Is there anything to that? Now, I know in this case, the mirrors are so incredibly expensive to build. So
a lot. Well, not just the mirrors.
Yeah, not just
there's an awful lot of stuff there that requires extremely high levels of expertise and years to put together. So you can't scale up to like an industrial build of these things. They're basically handmade from, by elves, and so to build a second one would take several years. Now, in the past, we used to send 2 planetary probes out. Like we sent Opportunity and Spirit.
2 Voyager missions.
And 2 Voyagers, 2 Pioneers. And there was some logic to that made sense. But this thing is, compare it to anything you want. It's an extremely elaborate, very, very difficult thing to build. People have done a fantastic job.
What's the one thing about it that you find most impressive, or I can't believe we're actually doing this, as opposed to something simpler?
Well,
That's not quite as good.
There are
but-
parts of the telescope that there are parts of this telescope that operate at 6 degrees Kelvin.
Right. Yeah, that's what I would point out too.
That turns out to be really, really hard. Because you have to start worrying about milliwatts of power being dissipated well away from there and radiating out onto those surfaces and causing them to heat up. It's
Oh, you're saying it has to be at exactly 6 Kelvin, or it won't work right. Parts of it.
well, or you want it to be around 6 Kelvin, or the noise goes up, right? If it goes up to 7 Kelvin, the noise goes up considerably. Yeah, it's
Is it Johnson noise or
thermal noise, but
It's an infrared
what
telescope.
kind of noise? It's an infrared
I said
telescope.
Johnson.
So it's basically it's on the sensor. It'll be noise on the sensor from essentially a stray light. Okay, and it will swamp even though this is a big mirror, the biggest mirror we've ever flown, it's the signals are still extremely faint because you're looking very, very at very, very distant objects. So, and you're splitting the light up when it gets into the when it comes off the secondary mirror, it gets split up and sent to different instruments. So you don't get all the light; you just get a part of it, and a significant chunk. So the MIRI is really the flagship instrument. That's the mid-length infrared instrument, and it's the major challenge getting MIRI to work. But what they were trying to do with James Webb is they said, look, we got great visual. We can do amazing things in the visual from the ground. There's no point in doing that in space anymore. We can build a 30-meter mirror and put it on the ground, and the visible light will beat anything we can put in space right now. But infrared, no, you can't do infrared without a space telescope right now, especially the medium wavelengths. And
Wait, so forgive my ignorance, but what's the basic reason for that?
Atmosphere.
Right, but so there's also atmospheric
blocks.
scattering in the visible spectrum, right? But they can use computers to correct for
It's not. It's nowhere near. It's not scattering. It's blocking.
I see. It's absorption by the atmosphere.
It's opacity. It's
Right.
the opacity of the atmosphere. Now you put a big telescope up at 14,000 feet in Hawaii or the Canary Islands or wherever, you get very, very clear skies, and with modern techniques for stabilizing the images, you can beat anything we can put in space for the next 50 years probably. But what you can do in infrared is really the whole motivating reason for having James Webb, and a lot of the early universe is shifted into the infrared, and also a lot of the planetary nebula and things like that, not planetary nebula, the protoplanetary disks, they want to study the emerging solar systems. All the science goals really require that. So MIRI is essential to the primary science goals, and it has to be really, really cold. And that takes enormous amounts of engineering, very complex engineering to make that happen. You have to have this sun shield that's about the size of a tennis court and a multi-layered thing that blocks all the stray light, all the sunlight, and not just the sunlight, but the heat from the sun, and reflects it away. And then you still have the problem of keeping that cold, because you've got these instruments up there with lots of electronics running and all dissipating heat and all. So it's even though they make the electronics as efficient as possible, they're still dissipating many watts. And where does that heat go? Well, it could easily just shoot out towards the telescope and in infrared radiation and just swamp swamp the sensor. So it's a very difficult engineering feat. Just keeping it cold. And the instruments themselves
write the
are
Wikipedia
absolutely
article?
state of the art. Say again?
Did you write the Wikipedia article that's going through a lot of what you're saying?
The article? I'm sorry, I don't understand.
Did you write the Wikipedia article? There's a lot of.
Oh, did I write the Wikipedia article? No, I'd love to actually, but no, my job on James Webb is very, very mundane and boring. You would not believe how much wading through documents it is. But I took it because it was.
in the kitchen,
Sorry,
potatoes.
Ciro?
No, I said Paul is the person that is in the kitchen peeling the potatoes for the crew. That's his job.
Pretty much, yeah. I'm the KP for actually, that would probably be more glamorous than what I do. But I took it because I wanted to help, and because I was bored as hell of what I was doing before that. So,
Hey, Paul,
and so this is it's interesting.
does the telescope have a safe mode in case of like intense solar flares and so forth?
Well, the solar flares aren't really a big threat, but it does have safe modes. Yes, it has safe modes and it has safe havens. It's a pretty complex system, but essentially, if something fails that causes it to temporarily lose control, it has a safe approach. Yes, and it's got that. The idea is to keep the sun off the telescope. That's the number one priority. It may take, if we have to go into that mode, it may take us weeks to get out of it and cool down enough to get back into operations. But everything there is redundant. There's if something fails, and something else will be switched in very rapidly. So
Is there an active
have a
cooling
very
system on? Is there an active cooling system on board in addition to the
Yes,
multiple
yes,
shades?
there is both passive and active cooling. Yes, the active cooler is a very sophisticated device that JPL built.
How long is that charged to last?
It should last the entire life of the telescope. It's not like a dewar with the gas boiling off.
What's the design service?
It's a
life?
compressor. It should last more than the service life of the telescope, something like 6 years plus. It's a compressor, basically. It's like a very, very fancy refrigerator, but it
That's
cools
why I
helium
asked how
down
much it was
to-
charged for.
Yeah, well, it doesn't lose helium, so it stays indefinitely.
There was a few years ago, the European Space Agency orbited the Herschel telescope, which also had to be cooled. And as soon as they ran it for several years, but as soon as the cooling fluid evaporated away or was used up, then they couldn't use it anymore.
Yeah, this is not that's a much lower cost way to do it, a much simpler way to do it. But if you recirculate the helium like they're doing on James Webb, you can go indefinitely.
Good to know.
So usually what they do is they'll recirculate nitrogen used to be liquid nitrogen, now it's helium, but it has to boil off at some point. And what they're doing here is they've designed it so that there's no boil off, there's no loss to space. So it needs the cooler to get down to those temperatures and remain stable. And the cooler's got lots of redundancy, and but the thing that scares me is that the helium lines have to go several feet from where the cooler is, through a deployable mechanism that goes up into the telescope. Actually, it's more than several. It's quite a distance into the telescope to what they call the cold head, and it protected by various bits that are also deployable. There's there's a lot of stuff going on there. There's more than 100 release devices on this spacecraft, which they're all what they call non-explosive actuators, which basically release a cable or release or cut a bolt or something like that. But they'll release all the launch locks and unfurl allow the sunshade to open up and unfurl. And the sunshade is in and of itself a very, very complex system.
Be cool if is
Because
there
you
gonna be any
have
way to get a visual on the sunshade opening up? Like if they have a little CubeSat that they launch.
There's no camera there. They
Yeah.
have a lot of sensors, but they don't have a camera. So unless you fly a satellite out there to take video of it, which would be actually a good idea.
Eventually,
I think Elon should
somebody
offer
will
to
do
do
it.
that for free.
You can see everything but itself.
Do we know if this is
Well,
the sort of thing where the kind of primary data collection, basically they have to point at a particular place for months at a time before there's enough data acquired to have some interesting results, or is
they can integrate for a long time, but typically they won't be integrating for months. Now Hubble did the deep field where it integrated for many months. They can do that with James Webb. Actually, they can do it but better. And they have more of the sky they can look at.
I'm just kind of curious if there's some, so the Large Hadron Collider for physics, they built it kind of knowing they were going to see the Higgs boson, right? Eventually, once they ran it for long enough, right? I'm curious if there's something.
Well, yeah, they probably expected to, yeah.
I'm kind of curious if there's like something that's the payoff that scientific payoff that NASA sort of went into this knowing they're going to get, or not. You never know for sure, but like highly confident.
Well, yeah, I mean, they wouldn't. When I talk to Tabby Boyagi and other people about this sort of thing, the way you get time on these very big telescopes is by having a fairly likely payoff. They will be looking at things like emerging solar systems getting vastly better resolution. They'll be looking at early galaxies. They'll be looking at all these, some of these galaxies, very early galaxies have big black holes in them. How did that happen? Well, if we get a better resolution look at them, maybe we can figure it out.
So what you're saying is that this wasn't really put up to find Dyson spheres.
No, although it sure could. If Dyson spheres exist. But the thing is, just nobody knows whether they exist or not. You're not going to get time to do that.
It has a chance to uncover biosignatures by studying planetary atmospheres.
Yes, it does.
It's a difficult experiment, but I'm sure they'll get time to do that. And the question is, which candidates will they try it on?
People are working on that. Yeah, people are working on that. In fact, with Hubble, people have detected specific gases in the atmospheres of planets. We did a show on that in Unseen Podcast.
Right. It should be easier to do that kind of experiment with Webb if it's working correctly. Yes.
Because
it should be.
IR wavelengths are more relevant. Is that the point?
I'm just trying to think, like, if you have oxygen, right? That's like the giveaway. You can't have atmospheric oxygen without life. So that's like a different infrared signature somehow, or?
Well, there's a lot of disagreement on biosignature gases. That there may be abiotic processes for producing oxygen that we don't know about.
Yeah, it's controversial. It used to be that people thought oxygen was a slam dunk, but other folks have come up with proposed mechanisms for producing oxygen without it, without biology. So,
some people thought phosphine in the atmosphere of Venus was a slam dunk, but there's no consensus on that at the present time. It's still debated, but there's no consensus
I think
either.
The only slam dunk that I'm still aware of is something like fluorocarbons. Something that's clearly industrial made. So that's more of a techno signature, to be honest with you.
Yeah, Avi Lev brought that up, but that bothered me. How much could it possibly be? Could you really? Is that really a practical thing?
Yes, because of the way
I don't know if
spectrums,
that
the way it would be an
yeah.
extremely weak signal. But the point is that you can isolate. I mean, that's basically how spectrums work. If you can get a signal at all, it's possible. Also,
Yeah.
You might have to have
interestingly,
a lot of passes.
there's.
I mean, we
that's
can't
right.
even like I don't know. It just kind of bothered me. Like we can't even get like this answer this phosphine question about Venus, and we could actually like look for this trace thing, and then I don't know. I just didn't. I guess I don't
Here's
know
the
much
thing.
about it.
Here's one thing to keep in mind. There is it's going to be very difficult to get one reading of one element in any atmosphere and make any conclusions. But there are certain mixtures that you can get that would be very hard to ascribe to anything but life. So I'm not an expert in this stuff, but I've understood that, okay, if you get oxygen and you get methane at a significant quantity, then it's kind of a whole different story. Now you have to be able to characterize the planet fairly well too, because for example, phosphine is very common at Jupiter and in gas giants in particular, yet we don't think there's life there because of that. So there's a lot of things that go into making these determinations. And I think the chances are that it's going to be one of these things where we're going to get down to percentages. You know, we're 50% sure there's life on this planet. We might not be able to do better than that.
Well, that but if you find enough planets like that, you might be able to get a pattern going.
Right.
So
it could become a statistical game.
Webb is going to give us Webb is going to give us a lot more detailed observations like that. Also, just how did planetary disks form? There's an awful lot of questions that are unanswered about that. Early solar systems are very complicated, chaotic places. So getting really exquisite imagery of that would be a big step forward. So
did you guys see the proto moon?
What?
There was a picture released from the ALMA observatory within the last month where they had a forming solar system.
Oh yeah, I saw that. A tiny little dot. Yeah.
But it was surrounded by a gas cloud that they presumed was a moon forming around the dot, which is significant because we haven't actually discovered concretely a moon around a exoplanet yet. So to see one possibly forming is pretty exciting.
Yeah. Well, we'll discover a bunch of those at some point, but anyway, yeah, Webb's gonna the science. If we can get it up there and get it working, which I'm optimistic we can. Yeah, there will probably be some obstacles, but they have a very, very. I mean, they have a lot of really top people working very hard on this. They should be able to get it into working order. I think pretty much on schedule. Now, right now the launch looks like it's in November.
There are at least 1,000 papers. Good. There are at least 1,000 astronomy papers that are out there that are saying we will learn more about this once Webb is up.
Yeah.
Cool.
And there's an awful lot of astronomers who want to get their get observation time on it.
So is the schedule already full for the first few years?
I think the first year or so is full. They don't want to cast it in concrete too early because they know they're going to discover things that will affect future observations. So, but they did have what they call the early science, and I think they updated that recently, and then they're going to go with that, and then they'll roll into another schedule as they go. And there's a committee that that reviews that, improves all that stuff. But
when they say they're planning on 6 years, is that like the usual NASA thing where that's like a super conservative estimate, and actually it'll probably be around for 20 years, or
20 years could happen. Yeah. And by that time we might even figured out how to service it.
right? Yeah.
The
Yeah,
problem
well, that's
is
why I
if you
asked
look
about the
at
active cooling
Hubble,
systems, because yeah, you can give
Yeah.
a really conservative estimate, but if the systems are sufficiently robust, they can last much longer as they have in many
it's pretty
different missions.
robust. I mean, compressors are everything that goes into space has to be 2x life tested. And typically when they get to the 2x, they're still going with plenty of room to spare. So and the thing won't normally need to use its battery. So the battery is not really going to be a limiting factor. Solar array will slowly deteriorate, but our experience of those is they deteriorate to a certain point and then they deteriorate much more slowly. So,
Are there like
micrometeorites will
actuators?
hit it.
Presumably there's some moving parts for repointing it, right? Or
Well, the compressors and the reaction
reaction
wheels.
control, reaction control systems, right? Those could wear out, I suppose.
Well, no, well the propulsion is not used that often, but they will eventually run out of fuel because what they have to keep it's not, the Lagrange point isn't stable. So now the fuel has been loaded up for pretty conservatively. I think it's at least 10 years. It's probably going to be a lot longer than that. And because the Lagrange point requires some station keeping, you can't just stay there. It's not a stable Lagrange point.
But it's less than would be required for other locations, right? It's pretty good. Was my impression.
It's not that much fuel required to keep it there, but this is a very big, heavy observatory.
Mm-hmm.
So
what's the mass? Is it
just nudging a little bit takes a fair bit of impulse.
Is it like 10 tons? I have no idea what type of mass we're talking about.
It's about 6,000 kilograms. It's big. It's about 6 metric tons.
So what happens if you don't station keep? Do you end up in a heliocentric orbit? You fall out of altitude?
You'll eventually drift off. Yeah. Eventually. I mean, it takes years, but eventually you'll spiral out of there and be in orbit around the sun. Not that would be a catastrophe. You could still operate.
No, that's where it'll end up once it's past its service life.
Yes. But you could still operate it, but you'd have to go to a lower data rate because, it'd be further from the Earth. So, I mean, Kepler, they just let it drift, right? And it was okay. And then until it, eventually died. But another one of my favorite missions is Stereo, which has been up there for a long time. And they drifted to the back of the sun, and now they're drifting back the other way. Stereo is, those are single string and they're still going. So, everything on there is over-designed, overbuilt, over-tested, tested
and
at
over
very
budget.
low temperatures, tested very well. Yeah,
And
it's over
over
budget,
schedule.
but
And over schedule.
no one should be surprised by that. You get to pick, right? Usually you get to pick, better, faster, or cheaper. Well, with JWST, they picked better. A lot better. And then faster and cheaper pretty much left town. And because they could see they weren't wanted anymore. And, and then
Like those first rovers on Mars, I understood that those were part of the faster, cheaper, off the shelf sort of thing.
well,
you
the
never
first
noticed
one
that?
was, yeah, but
The very first one. I'm not talking about the most recent one, which is, another feat of amazing engineering, the way they lowered those down.
Those are
and
billion
dropped
dollar
them.
missions. Yeah.
Yeah. I'm talking about
Yeah.
the very first one.
The ones that dropped in airbags and bounced around. Yeah. Like, what was this name? Pathfinder. Was that what it,
Yeah, I think so.
I can't remember it, but yeah, that was um, that was meant to be better, faster, cheaper. And what better, faster, cheaper, I think was a very important thing to do because it taught us, yeah, we can do some things cheaper and better and faster, and we should strive to do that. But if you're going for something that is unprecedented performance with very ambitious science goals, you're going to have to and and you're going to spend so much money on it that you don't want to launch it before it's ready.
Yeah,
So,
you don't. Yeah,
you know-
you don't want to compromise on that. Just like in Sam referenced the LHC earlier. They that has to be built
Yeah.
to certain tolerances if it's going to do its job.
Although you mentioned launch,
Right.
the launch is like, there's elements of irreducible risk, right? Which make the put all your eggs in one basket strategy a little bit scary. So somebody, you said it's
Yeah.
launching on an Ariane rocket. Is that right?
It's going on an Ariane 5, yeah.
Right. So whoever the mission controller
it-
for that is going to have like a very stressful day.
Well, that's every space mission goes through that, yeah. Launch now. I think this is probably the most scrutinized launch.
In a long time, yeah. For non-human,
most
unmanned
scrutinized
launch.
non-crewed launch
Yeah.
in a long, long time.
It's got to be 10 times
The,
more stressful to launch a $10 billion satellite than a $1 billion satellite, right? I mean,
Luckily, we're
yeah,
not,
it is.
responsible for the launch.
we're not.
Well,
You say the Europeans are?
Meaning the range.
Ariane's,
Onward.
yeah, ESA. Actually, the Europeans paid for the launch. Yes,
Yeah.
they're paying.
And it's
for the
happening
rocket.
in South America.
French Guiana.
Yeah.
Yeah.
Yeah, French Guiana. This is a very mature rocket with an excellent record, and it's launched many, many times. And the French Guiana site, of course, has been in use since the early '80s, I think. So they have a lot of experience. And they blew up a lot of rockets in the early days, just like anybody else does, but they haven't blown one up in a while.
Mm-hmm.
But they had a bit of a hiccup, so nothing's given.
They've had some hiccups, yes, and that's why we're not going until November, because we want to make sure that the fairing. They're being super cautious with this, by the way.
Right.
It's really, really conservative, but the fairing depressurization and the fairing separation. Now NASA's been bitten by fairing separation before, so with something called the Orbiting Carbon Observatory, which they lost 2 of them to bad fairing separations, now the fairing works on Ariane 5, but the problem is we want to make sure that the pressure inside the fairing when it separates is very low, so there's no pressure difference. And boy, there's been a lot of work done on that. It's just a tremendous amount of work. Millions and millions of dollars spent on this, both by the Europeans and by NASA, to make sure that when the fairing pops off, there's not like a big bubble that that
Have
comes
the
out
Europeans
and
been-
damages these very delicate.
Have the Europeans been promised a certain amount of telescope time in exchange for their investment in the program?
I don't know what the deal is there. I suspect that there will be a lot of European researchers that get telescope time, but
We didn't just pay them for the launch?
no, we didn't pay them.
Oh, interesting.
If we'd paid them, we probably would have gone with the U.S. launcher, but
Thank God we didn't pick Boeing.
Right. I was going to say that might not have been a safer choice. I mean,
We'd have 10 more years.
or something, right? I mean, like.
yeah,
More
the
years
thing is,
to
yeah,
go.
they considered lots of.
Right.
Yeah, Ariane was picked pretty early on in the because they had a big rocket, Ariane 5, and they had maturity, they had experience, they had good reliability record. Uh, so it was really, and Issa wanted to do it, so it worked out. Uh, they are everybody. There's been an enormous amount of paper gone back and forth between NASA and Issa, and every possible minute detail of the launch. Everything from the air conditioning and the fairing to, what kind of shoes the people need to wear on the integration floor. It's everything has been just very, very detailed.
So, Paul, can we maybe switch to another subject? I think
Sure.
the Galileo thing with Avi Loeb is worth mentioning and talking about. See what people think about that whole thing.
Catch me up.
Yeah.
Yeah.
I'm on the fence about it, but I think that for a long time I've been advocating that we should look at our own solar system for, I mean, it may be a long shot, but for signs of past visitation. So far it's been a null result, but I was hopeful that maybe we'd see something on Ceres when Dawn got over Ceres, but nothing that wasn't explainable by natural processes. So, because I figured, well, if they're going to come into our solar system, they want to get to a nice small airless body and mine it, right? And well, they didn't do Ceres, so.
Static's back.
maybe-
I'm sorry.
Yeah, go ahead.
Rock, what's your view on the subject?
Well, I follow the astronomy community very closely, and they're of course very anti Avi Loeb, but I personally think he's pretty courageous, and what he's doing is important and interesting. I particularly like the fact that people like Beatrix Villaloral joined up, and I heard her speak a couple days ago on the Event Horizon podcast, and she said it took her about 2 seconds to decide to join that group, which is just great. And I don't know if you've seen her latest paper, but they've uncovered a picture from a 1950 I think it's Palomar data set, where there were like
Palomar, yeah.
9 objects that showed up in one of the emulsions, but not the other. And it was like back in 1950, so that's pre-satellite age.
So can someone give us a sketch of a background of the new group that's been formed? I'm not aware of this.
In rough terms, this whole stuff came down with the UFOs, information being released from the government and so forth. And Avi Loeb stood up and said, we should treat this data set seriously. We should do other scientific experiments along these lines to really look at this and trying to come up with an explanation. And so this looks like it should be funded. And lo and behold, he got something like almost $2 million of funding from anonymous donors to go do this. So he set up the group and made a big announcement, big press release about, we're going to go check out this data. We're going to collect our own data. He's got a whole bunch of things he wants to do. Not a huge amount of budget, but he wants to, take science, to have a scientific group that will take this UFO stuff a little more seriously. He also wants to try to find more Oumuamuas in data that's already being collected. And he has a few other kind of pet things he wants to do. But basically, we're looking for artifacts on the moon and other places. There's a whole gamut of things that fall into his bailiwick, of things that have been kind of neglected by the scientific community that he thinks should be pursued. He called it Galileo. This is controversial. He called it Galileo because he considers himself a bit of a martyr. which is a little bit sad
What do you want me
in
to
my
do?
mind.
I'm sorry. Oh,
Well,
okay,
I
yeah.
recently listened to the whole of his book, Extraterrestrial, so I got a good dose of it there. I have I doubt much will come of the
Does it
so-called
have a
UFO
password,
data,
or
but I will
is
say
it-
that
Okay.
it's probably good that he and several
Um,
other
let
scientists
me
are
text you the
actually
password.
becoming involved. So because the UFO
All right.
community in the past
All right.
has always talked about nobody will study it, and when they've tried to finance their own studies, they haven't gotten people who knew what they were doing. But with people who do know what they're doing, they have an actual chance of doing some research that will yield knowledge, and that's certainly a good thing.
I
So-
couldn't agree with. Go ahead.
Oh, sorry. I just so to be clear, is he looking for something that like as he was first talking before, like he imagined a cell phone in the Stone Age? Was he looking for things like that? Something was left over by accident, or is he looking for active spy satellites? Or both?
Yeah, he's got kind of a laundry list, and it does include those things and others that he thinks have been neglected and could be pursued.
Yeah, interesting question. Like how well you could actually hide some kind of satellite that could still record if your goal was to hide it. I wonder.
Well, he
Yeah.
specifically mentioned satellites in polar orbit. He thinks that would be the way to hide them. I don't know if that's true or not.
The main page for Galileo's activities focuses on three broad classes. Obtain high-resolution multi-detector UAP images, search for and in-depth research on Oumuamua-like interstellar objects, and search for potential ETC satellites. I assume ETC means extraterrestrial civilization.
Yeah.
Right, but also just note that he has hired a fairly eclectic list of researchers, many of whom have their own little agendas that they'll also be pursuing. So, but you're right. That sounds like that.
Paul, we can't.
Well, that's how it always is. Science. You bring a coalition, and they kind of.
Paul, your sound is so bad it's not comprehensible.
You are in space, Paul. You're in orbit now.
The aliens are speaking through his microphone.
Yeah, you're channeling aliens.
Well, I just unmuted it and then muted it again. Okay. How about now?
No,
We're back to the echo.
We can hear you, but it's very fuzzy and distant.
distorted, very distorted.
Yes, very distorted.
Okay. I'll mute until I fix it. You guys keep going.
All righty, Paul.
I mean,
Maybe a cable, maybe a loose cable.
it did sound like it was feedback.
Test.
Yeah. At first there was feedback,
Test,
then
test,
now
test,
it's
test.
become completely distorted though. No,
Yeah,
at first it was delayed actually. At first it was delayed.
Yeah, but I think it was like the headphones were going to
Yeah.
the speaker or something.
Yeah.
Well, I think another new initiative or new piece of news that's worth mentioning is the $100 million that came out of nowhere for solar
Test, test,
power satellite research.
I didn't hear about that. Which
There
project
was a story from IEEE. Solar power from space, Caltech's 100 million gambit. Billionaire makes secret donation for electricity from orbit by Ned Potter. I actually heard about it because I'm part of the mailing list. I'll put the link for this story in the chat.
Test.
I'm part of a mailing list of solar power
Test, test,
satellite
test.
stalwarts. Keith Henson, who was an early founder of the L5 Society and has been involved in solar power, is his list. And there's a lot of really, these guys have been at it for decades and they've been thinking it through for decades. But my guess is that now that the Chinese have shown an interest in solar power, that others want to
Test,
see
test, 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 test.
others enter the field as well, and
Test,
not
test,
just
test,
give
test,
it all
test.
to the Chinese, as it were.
Isn't the plan to, well, at least some of them, to use the solar panels themselves as like a solar cell by like drafting, like the way sailboats do? There was some kind of thing I remember reading about this.
I don't know about that, but there's many different designs, and there's many different programs that have been proposed. You know, the most obvious thing we know from satellites is putting a bunch of solar cells up and just using solar electric. But from what I understand from the people on the list, is that it's more efficient to actually use the solar energy to run some kind of a generator and then convert that into electricity and then beam it to Earth in the form of microwaves. But I'm
beaming it to Earth in microwaves.
Yes, I am in no way, and I don't know very much about this. I'm not well read about this. In fact, I gave a presentation in 2019 in which I said this is a future that's never going to happen, because you know the lobby that will shut down microwaves in space is going to be pretty obvious. So. But I support the research. I think it's a great idea. I just don't think it's as a practical program that's going to, though it could be a very big player in terms of electricity for off-planet settlements. Whether
that was O'Neill's proposal back in the mid 70s.
Yes, yeah. And O'Neill's proposal was it's important to understand. He saw that the rug was getting pulled out from NASA in terms of funding large-scale missions like Apollo, and he wanted to find a way that space settlement could be funded. So he proposed this huge program for power satellite construction, because this was going to be the hard economic reason that was going to make space settlement possible, and you would have, quote, millions of people living and working in space, unquote. I've talked to people who don't really get that, and they say, why is this O'Neill program so people heavy? We could all do this mostly with robots, right? The whole point of it was to get people living and working in space. It's an economic facilitation of a space program that wouldn't happen without that economic incentive.
You know, certainly. I mean, O'Neill's really driving objective was to move all heavy industry off of the Earth. Back, you know, that was the first problem he started. I think it started as an undergraduate class. He was teaching. He said, should all heavy he asked them a question, should all heavy industry be on the Earth or in space? And the students came back with in space. And he said, well, how do we do that? And that was the genesis of his whole campaign that he went on.
Well, the
was
famous,
that driven
the
by
famous
environmentalist
question,
impulses?
Somewhat, yeah. But he was a high energy physicist, and a very good one.
Yeah, he was the one. He was the one who made possible the large scale superconducting super colliders that we have. And in fact, he was, by many reports, kind of bruised by the fact that he did not get a Nobel Prize for his distinctive contribution to particle accelerators, which are basically made possible by his work.
Yeah, and he was a brilliant man, and I heard him speak once, I think in '78, and he was quite an inspiring speaker. There was a room with about 1,000 students in it, and they were all up and cheering.
The famous question that he asked his early groups at Princeton was, is the surface of a planet the best place for an expanding technological civilization?
Yeah, that's I think that's how but eventually he started stating it in terms of,
right,
we want to get heavy industry off the Earth. In fact, Peter Thiel,
but it's very contentious, right? The
this
answer
week,
is
Peter
not
Thiel
obviously no to that question.
Yeah.
Like, I mean, I would lean towards yes. The heavier,
I'm a huge proponent of avoiding gravity wells and as a general practice, except for research purposes.
It'd be interesting because, like, you really would have to think about this problem, because everything relies on the fact that we have this atmosphere. We have as much of it we want. We have these Earth that we just sink electricity into, and wherever we have too much anywhere, we just ground everything out. So in space, it'd be a little bit different story. So you can't just fume hood something because it's just gotta stay there. It's not gonna go anywhere. It's not gonna go drift out into the ocean and be taken care of. So I don't know. It'd be.
But it might be. I don't know. Maybe he has written a bunch of papers about this type of stuff. But like basic industrial processes, like aluminum smelting, or the way they get nitrogen-based fertilizers. Do some of these things benefit from being done in space in some way?
Well, the whole thing about the whole question about whether or not gravity wells, there's gravity wells, civilization to be able to expand in a planetary environment, or where there's gravity, or in space, it becomes more complicated once. I mean, even if we settle that the colonization should happen into space environment first, outside of a gravity well, it becomes more complicated once this hypothetical civilization are going to start growing more and more, because now we're going to start introducing the whole question about are humans going to be able to live for an indefinite period of times without gravity, or are you going to introduce artificial gravity? But when you start introducing artificial gravity, there's a set of other challenges and questions depending on the scope and the magnitude of a structure in space. So it's not as straightforward to say, it's so much straightforward to say we should go ahead and I think there should be a symbiotic. I think what I'm saying is I think we should explore both things. I think we should explore the the expansion into space environments and building of structure and building of working environments in space and also on planetary surfaces. Both, yeah. I think
it's interesting to note that in the original O'Neill plan, I should mention that I was an early enthusiast of O'Neill. I got the paperback copy of his colonies at the
High Frontier.
What was the name of High Frontier? I got a paperback copy of the High Frontier at a book stand in Astoria and read it through until there was nothing left of it, and was completely captured by the vision. Anyway, what I was going to say is that a large part of O'Neill's program was mining the moon for resources. So there was going to be industrial infrastructure on the surface of the moon that would then be thrown by a mass driver and then collected in orbit and then towed to L5 for the manufacture of settlements.
Exactly. That's exactly what I mean. You need to have a symbiotic relationship, if you want, between the expansion of a possible space settlement and also the ability to leverage planetary resources, right?
It's going
to the extent, what do they got on the moon? Like an awful lot of silicon dioxide, right? I mean, like just kind of like
three.
But it's going to take a very long time to build up an industrial infrastructure in space. Yeah. Although recently I've been thinking, one model that I've been meaning to read up on, but I haven't yet, is since Australia was industrialized so late and there was very little civilization there prior, you have a nearly pristine construction of an industrial infrastructure in Australia after the British began using it as a penal colony. So it might be interesting to study how rapidly various industries took shape in terms of steel foundries and then precision machine tools and all the things that an advanced industrialized economy needs in order to create tools to create better tools.
Although the British were motivated a lot by resource extraction, right? I mean, Australia has a lot of mineral wealth.
But I honestly, this is just something I've been thinking about reading, but I haven't read up on it yet. So my question is, were they deriving resources before they were using it as a dumping ground for convicts, or did the dumping ground for convicts come first? It was just a distant and inhospitable place full of highly toxic animals that you could put people that you never wanted to see again.
Right, but California was sort of similar, right? They built up an industrial infrastructure in California starting in the 1850s. That case was clearly driven by resource extraction, as the initial impetus for putting in place the infrastructure, right?
Yeah, if you want to call gold resource, it certainly is a resource extraction, but it involves so many, gold fever and human factors of people were willing to come to California in 1848 or 49, excuse me, to mine gold because of gold fever, basically. But that, of course, that wasn't the only thing. It's very complicated how any industrial infrastructure gets built.
So you
I will
have
say this as a quick sidebar, is that just recently they've reevaluated how much carbon dioxide is actually residing in the Martian poles. And the upshot is that most of the models for terraforming Mars are now kaput. So that's kind of an interesting sidebar.
Meaning nuke the polar caps is off the table.
Yeah, it's not enough there as far as building an
Oh,
actual atmosphere.
that kills
So
my
it's not,
plans next month.
it's not going to be like at the end of the Arnold Schwarzenegger movie where they press the button and the alien machine fills up the atmosphere in a few minutes.
Oh, that's totally plausible. Oh, that's totally plausible. As long as it's fiction. As long as it's fiction.
Paul, your audio is crap again. We had you. We're pretty clear for a while, but right now you're sounding like a heavy breather on the phone, making an
Like
anonymous
Darth
profane
Vader.
call.
One thing I was thinking,
Better?
it's a
Better.
Yes.
There you go.
I'm not happy with this thing.
Must be a cable. Is it a cable issue or?
No, it's my A to D. I'm thinking of getting rid of it. Anyway, it's expensive too.
Are you talking about the audio interface? Is that what you
Yeah.
use? Ah, you got a Foster? No, you could not probably talk about brand. I don't know.
It's a Focusrite, but I'm not
Yeah,
happy
that's
with it. No,
The Focus, right? That's what I was gonna say.
it's supposed to be more high end than that.
Well, is that under warranty?
No, not anymore.
Not anymore.
No, I'll have to sell it to somebody who thinks that it's good. I've got a lot of stuff sitting around my house that I need to sell, by the way.
Got to raise money for your Blue Origin ticket, right?
No, just need to get rid of this stuff. It's just in the way. I have a PC that's perfectly good. I can't get rid of it. Anyway,
Anybody been following? Well, I'm sure everybody has, but how close? I don't know. Anybody been following relatively closely the progress of the SpaceX Starship development?
oh yeah,
Yeah.
really cool.
Yep,
it scares me every time I look at it. But I think there's going to be another explosion any day now. But we're almost used to the explosions at this point. But the next one's going to be really big. I think they're actually doing the right thing, but
They're going too
the
fast?
odds of something going wrong are pretty high.
Yeah, well,
It's been changing the way my job. I've been grabbing like all those people who write these like posts talking about the SpaceX culture. I've been trying to bring it into where I work, and it really does seem to work. It's I don't understand why it works, but it shouldn't, but it does.
are you referring to the manufacturing process or the entire?
Well, what we've been
like
doing
chain,
is,
entire chain?
and I hope I don't offend anyone here as a contractor. We pretty much, in my job, I pretty much brought this up that SpaceX doesn't hire contractors, and they buy it off the shelf or they make it themselves because the communication issues between different groups, people, causes too many delays, and delays actually end up becoming cost overruns. So we pretty much got rid of all our contractors, and we muddle through it. That's it. We'll hire someone to teach us something we need, but we don't hire out work anymore. And that's another thing. And also we've been more itinerating our work now. Like I pretty much drew up, we have like the standards. We have like this relatively standard system, and I drew up this is where I want us to be in about a year. But we can't get there right now. So we're going to do this little improvement, and each one is just we're going to have to just do one by one until we get to it, rather than throw everything away and just starting with a fresh design. So I've been trying to like incorporate that in. And it does work.
If you don't mind me asking, do you do industrial machinery manufacturing?
We do, and we also put our systems to other people's systems. So both. We own the patents to about four processes out there. So we take the patents and then we'll build the whole system, electrical controls and the machinery itself, and sell it direct. But we also, there's other companies that own they'll make the skid or the system, and then we'll integrate into them. So both. It's pretty common in this industry. You work for your competition, you work for yourself.
Good. That's interesting. Yeah, I mean, obviously they're revolutionary. I mean, SpaceX, I love them or hate them, right? They've done a lot of things that people would have not been willing to bet on, maybe 15 or 20 years ago. So I guess that's the
5 years ago.
Well, maybe even 5. Right. Well, I mean, they're not super fast, but I mean that's kind of a relative term too, I guess.
They're fast. I mean,
it's super fast compared to SLS.
compared to what it would take any government agency to build a rocket that size, they are super fast.
Absolutely. No, I agree with that. What I'm saying, I guess, is that they've had their share of delayed timelines.
Yeah. Oh, sure, but
Right.
it's Elon time.
Right. So what's the mission that this big rocket is going to do? Is it going to go up in two pieces, and then each piece is going to come back separately?
The first one they're going to both fall into the ocean, right?
Well, the first one is just a test, but
a test, right?
Yeah, the main thing is they want to test the Starship coming through a significant chunk of the atmosphere, and re-entering without blowing up, basically.
So is it going to take it up to into orbit, or just
not quite orbit, but pretty high?
Pretty high, and then it's not going to It's not going to be in full orbit. It's going to go from Boca Chica to about Hawaii.
Hawaii, roughly Hawaii. Yeah.
Are they going to throw it in the drink or recover?
Yeah, they're going to try to recover the Starship, because they want to see the damage to the thermal protection system.
The heat tiles, right?
Yeah. They'll have hopefully pretty good video, but they'll have what they want to do is basically so far they've only taken it up. They haven't taken it up very high, and they haven't come down very fast. So what they want to do is they want to come down at full speed, and in the test they've done so far, they didn't have a thermal protection system because they didn't need it. But this one they'll have the tiles on.
It's going to re-enter into the. It's going to get some plasma interaction. Right? If I'm not mistaken, right?
Yeah, it'll be a real re-entry, and the odds of it working are roughly 50-50, I think.
But
they're going to throw away the big booster.
Lighting all the booster engines at once, right? I don't know if they're going to light all 30.
Booster's going to end up into the ocean as well.
Yeah.
So I would think that they're going to try probably recovery as well of that one.
I don't know if they're going to recover it or not. It's very large. You'd have to have a hell of a ship to pull it up, but.
That's what I was going to ask, if they can land that big booster on legs like they do with their other boosters.
They're not going to use legs. They're not going to use legs on either system. The legs just turned out to be too heavy, so they're going to catch it.
Yeah, I saw an animation of that, of how they're going to catch it on the way down.
It's really
the gantry.
They call it the Mechazilla. The Mechazilla comes up and just grabs it, and then sets it down gently on a platform.
So at what stage in the mission is it likely to blow up? Launch probably is pretty likely.
No, launch. I think they got that down pretty well. Well, I mean, the booster could blow up at launch, but
the max Q, right? Could blow up at max Q.
XQ, I don't think it's going to be. I think it's going to be re-entry. Well, and if the booster gets through its boost phase and separates, which is pretty. I think I'm better than 50-50 on that. But re-entry for the Starship itself, first time they tried that, it's gonna be. It's gonna be.
But it's not likely to
scary.
be an explosion, right? That it would just
Oh,
kind of fall apart.
it would explode. Yeah, it's got a lot of methane and oxidizer in it.
They blew up into the water before. As a matter of fact, there was a launch that was coming back. I think it was one of those midlife, so to speak, midlife launches by SpaceX, where one of the reentry was supposed to be on the drone ship. I think. Oh no!
Oh, it's had problems where it either missed the drone ship or it
went outside the range of Cape Canaveral. I mean, it went outside the land and ended up into the water and blew up. Into the water.
That's
When it hit
happened.
the water, right? Yeah.
Yeah, but that may happen because there's still tons of methane and oxidizer in those tanks, and if they rupture, you get a boom boom.
Elon was actually complaining about how much extra fuel they have.
Yeah.
He
Well,
did this long
you've
interview
got to have
on
some
NBC.
margin. You can't come down with zero, but you got to have. You don't want too much either. So,
Or you might need to readjust your device again because you're becoming more and more static again. Just to let you know.
But in that interview, Musk was very emphatic that on the launch pad, there might be a fireball, but it's not going to be an explosion per se. If when the engines are lit. Trying to downplay the analogy to that big the Soviet N1, I think, the one that blew up.
yeah.
Yeah, it's a risky business. There's no doubt about it. Risky business. But Musk has got I think that Musk has got such a I don't know a religious following. I don't think that that people almost don't care anymore about SpaceX's failures. I mean, he's been having so many failures that have turned into successes that I almost think that further failures are almost going to be expected. Depends.
Well, see,
Depends on what kind of failures, I guess.
That's the advantage they have. They can blow something to smithereens and say, a learning experience.
The equation is going to change once you start putting human lives and something bad were to happen. I think things would
well, right,
change.
but they've done that with Dragon, right? And it's gone well so far.
No, I know. That's what I'm saying.
But the early NASA space program failed often too. I mean, they blew up rockets and they lost probes.
Yeah, you could do that. You could do that then.
Yeah, it was a failure was acceptable.
And test pilots were being buried in the desert on a pretty regular basis.
Right.
And
that's what it takes to be successful.
And everybody said, well, that's the risk test pilots take, and that's the way they live and the way they die. But nobody has that attitude anymore. It's like,
failure is not an option.
Failure is not an option. Safety is paramount, even to the point of sacrificing everything else, including
the mission.
Yeah.
Including the mission.
Well, let's
ever flying.
Well, the thing is though that let's also be fair when we're talking about failure of test flights, right? Is one thing, and well, granted that I'm kind of getting at the Boeing. The old Boeing debacle with the CST-100. I mean, granted, that's supposed to be also a test flight, right? That they are repeating because the first one, we know how it went, it didn't go well. This one is a repeat. So they are being extremely careful. They don't want to fail this one either. But at the same time, other than this one, I guess what I'm getting at is that we have to be also thinking about when you're talking about real actual missions, not necessarily test flights, then it's a little bit more, there's much more at stake. You don't want to fail a mission, right? Where there's a payload.
Well, sure.
That's
why you do all that testing.
what remains to be seen is with when private people like Musk and Bezos create their own space program, even if they fail, they can continue to put their money in. So that's one incredibly enormous difference between a national space program and a private space program. Is if you fail, then if you have a debacle with the national space program, it becomes a political issue, whereas a billionaire can just keep putting their money into it. What we have yet to learn is if this can also overcome deaths in failed missions. So when they do send people up, there's a lot of room for people on a starship. If they send 20, 30, 40 people up and they all die, it could be an excuse for a government to shut them down. But if the government does shut them down, will the industry be able to continue to operate after a debacle that involves large loss of life or even small loss of life?
But the other thing
we have planes.
But the other thing is that when you're talking about, I hear your point regarding, that they are private companies in a sense. They are, I guess, quote unquote, more free to fail, I suppose, if you want to put it that way. But we also have to keep in mind that a lot of the missions, more and more, right, the actual mission that they're doing now, they have in a lot of contract with the military organization, with the Air Force, with the Space Force. So in a way, the tolerance for failure in those cases become reduced.
Right. I agree with that. But the Space Force isn't right now buying 30 seats on a starship.
No. But they got pretty expensive military equipment that they're entrusting SpaceX.
Yeah,
right.
Absolutely. They have to have. If they didn't have a good record, all that would be sunk.
Exactly.
But they, as a private industry, they can continue to put money in even after a failure in a way that a government cannot do without it becoming a major political issue.
Definitely less than what the government, but I think that there still would be vulnerable to the public opinion. Like you said, when there's a mission where human lives are getting lost, several human lives, then you start, talking about the public opinion, the
marketing problem,
public opinion, and even regulatory, because even though they're a private firm, they still have a large amount
subject to regulations. Yes.
Yeah, exactly. I mean, you're talking about the FAA is always involved, and other agencies and everything. I mean, they can do whatever the heck.
And I said, they may get shut down by the government. I hope it doesn't happen, but if there is a catastrophe with loss of life, it could happen. But I'm just posing as a thought experiment. Suppose they have a catastrophe with high loss of life, and the government doesn't shut them down. Will the industry itself will it accept those losses and continue, which is the only way that any success will ever be had, or will it just collapse from within and the momentum will be lost?
Well, man, I don't know about collapsing, but perhaps delayed by several years, right? I mean, I don't know. It depends on the resiliency, right? Because obviously, if they start losing, I mean, now SpaceX is going to make more and more money also because of all the contracts that they're winning. I mean, they're getting a boatload of contracts now, right? From NASA, from the DoD. So that's a lot of cash. We're talking about billions of dollars, right? Coming from the DoD and from NASA as well. So if they were to lose those, then
I think it's more likely that those customers would prevent SpaceX. SpaceX does some Mars launch with a few astronauts, and there's an accident and they all die. But because the military is dependent on SpaceX as a launch provider, that would actually probably protect SpaceX and prevent the regulatory intervention that you're worried about.
I do see Nielsen. I mean, I'm kind of thinking like what you're saying is that it's like a 3 Mile Island incident. It's this thing that happened. The optics were really bad, even though it wasn't bad in itself, and it's not reflective of the industry. It's still stopped nuclear power for 50 years in the first world.
It still stopped. The industry is dying.
I just think there's not going to be any events like that like there's not going to be huge numbers of people flying for a very long time, and so like
right. But let me
not-
give you another scenario that doesn't involve loss of life per se, and that is, what if they're able to actually find primitive life on Mars? Then there's going to be a huge problem with allowing Musk to go ahead with his vision to put people on Mars, because there's going to be the question of protecting that Mars life, and also the potential for reverse contamination and so forth. So there's a scenario that doesn't involve loss of life that could have major ramifications. I mean, the cynic in me says that NASA has been so careful about their missions to Mars that they've almost been set up to not discover life, because they know if they do discover it, then future missions might be in jeopardy until things get figured out in that regard.
Well, one way you could do an end round around that is get your astronauts on Mars first before they start doing science, and then they can do their science and discover life after they're there and have set up some kind of a base.
Wasn't there some famous incident where like the Supreme Court or some judicial body made some decision and the president didn't like it, and they said like they've made their decision, now let them enforce it? That's kind of what I think Musk's attitude would be to the Planetary Protection Office.
Andrew Jackson.
I was going to say, isn't that Andrew Jackson who said that?
Yeah, right.
That's a good point. Actually, I do like the
one thing I would point out
Nick,
about that possibility is that well, it, you know, they SpaceX just said yesterday that it's going to take 8 fueling trips plus the depot launch to get that to do the human lander, right? So let's just say, for the sake of argument, to get to Mars, it's going to take, I don't know, 12 fueling trips, 1 depot launch, and then 1 human cargo ship. That's a total of 13 launches. If we assume that the probability of a failure is equal for each one of them, that means that there's only 1 in 13 chance for every group of humans you send that would kill them, basically. That would massively reduce it, right? I mean, you're only.
How many launches are you talking about? You mean the refueling launches?
Yeah.
Launches?
So like,
well,
they're basically
one can fail, and you just replace with another one.
Unless, but maybe Isiah is saying if they have 12 launches to fuel up the interplanetary system,
Probably less than that, but yeah,
on the 13th launch, they're going to launch the astronauts. Would NASA let them put astronauts on their 13th launch unless all 12 of the first launches went without a hitch? You know, like.
Yeah, it's you're having a lot of opportunities to get it right, and if it's, you know, they're independent of sorted events, it's, you know, it's just 1/13th of a chance that something will go wrong. I mean, I'm not talking about the moon one. I'm talking about the potential for the Mars one, which is probably going to have more than 8 fuel.
I think it might actually not be that much more. I think there's some funny. I don't remember the details, but I think it.
So it's 8. It's still 9. It'd still be.
I don't remember
8 flights plus a deep boat. It's 9 plus the humans. That's 10. So
I think the point is that the way the moon thing is set up is really stupid, and so it's like very surprisingly expensive to do the moon system the way NASA's thinking. Like you might.
Yeah,
well,
they're going to boost up astronauts
Mars.
in their own rocket and then shift over to a SpaceX, which could do the whole thing to go to the moon. I mean, it's great that they're going to be using SpaceX to go to the moon, but yeah, I agree. It's a really dumb mission structure.
And they're still using the gateway thing, right? Which is also kind of counterproductive.
Sort of like it's a chance to use all the toys. Well, NASA's last big rally before private industry takes over these, you know.
But I guess my prior is that it's sufficiently stupid that it's probably actually not going to happen. But maybe I'm too pessimistic. Like,
oh well, stupid has never prevented anything before.
Well, it's actually you can think of a Rube Goldberg mission structure as being a stronger test of the hardware and of all the systems and as well as the astronauts and their capability. And it's just like
and it's a political play that helps protect the mission and from congressional cancellation, right?
When countries are trying to build a nuclear weapon, under the current test ban regime, they want to do as few tests as they can to get the least amount of heat from the international community. So each test is made really severe, and then the other people who, the big countries like the U.S. who run sensor networks and pick up the seismic waves from these nuclear explosions, they can't tell if it was a fizzle or just a really severe test. And so there's actually an advantage in that, in having a really severe test of your hardware.
Gentlemen, I'm gonna check out. I'm sorry it's getting a little late here. I just wanted to say good night to you and enjoyed listening to your conversation.
Thank you, Jim. Good to see you. Hope to see you again next time.
Okay, thank you. Bye-bye.
Take it easy.
Bye-bye.
Can I make about the Drake equation? I had something popped in my head this week about it.
Your microphone, Paul.
Here, or?
You were static again before.
Me?
I was asking Paul to see if his microphone was fixed or not.
Paul was sounding difficult to hear again. Go ahead.
My microphone was.
Oh, now it's fine.
Yeah, it's not the microphone. It's something else on the chain. I don't know what it is.
Now you're perfect. But like last time, you were still.
Well, I've got a preamp and then another amp and then a digitized. I don't know. It could just be Zoom. I don't know.
Isaiah, what were you going to say about the Drake equations? Because I guess
I was just. This might be totally out of nowhere, but I was just thinking about this. They're saying how like they're at these rogue planets and right, there's these gas giants that not lit by any stars, just flying out there, right? So you got to make a list of things that have liquid water on it, or at least we think they have liquid water solvents on them in our solar system. You come out with more moons than you come out with planets.
Mm-hmm.
Right. So my question would be, if we're saying that Europa might support life around Jupiter, why can't these rogue planets support it? And if so, why is the Drake equation first term habitable stars? Maybe that shouldn't be there. Maybe it should be something else.
There have been papers written on the possibility of life on rogue planets, because now that we know that liquid water can survive under many kilometers thickness of an ice, if there's any kind of processes going on that can maintain some heat, so if there's residual radioactive decay or there's some kind of still life left in the core, or both, you could potentially have a situation where there's enough energy gradient and enough resources that you could maintain some minimal form of life on a rogue planet floating through space.
Well, why can't it be like? I was just saying, why couldn't it be around like Europa, around the rogue gas giant? And
right, because then you'd have to entirely depend on tidal forces to provide the heat. So you'd have to do that calculation. It'd be pretty strict, but I think it might be doable. Yeah.
Are you suggesting exomoons around rogue planets, like rogue moons? I suppose, is that what you?
Yeah, I'm just saying, if Jupiter just got thrusted out in a billion years or something out of our solar system, taking Europa with it. Yeah. I was just wondering if anyone's said okay, we got to modify the Drake equation because we never considered this situation that there are rogue planets. There are rogue. Presumably, some of them would have rogue moons.
Jupiter conditions will change.
I wonder if anyone's
Jupiter conditions will radically change though once you start throwing it away from the current orbit, right? Now it's not going to be Jupiter.
Right. Yeah. So there'd be the parameters are hard to pin down because presumably there's a relatively small and celestial timescales window.
Jupiter away from the current orbit. I don't think that the geochemical conditions are going to be exactly the same. I mean, you still have a solar influence, you got some certain gravitational influences, I mean, you got a lot of interactions based on the location, right, and the current orbit.
Right, but the interactions between the multiple satellites, the multiple moons, is stronger than the solar interaction. So you could still do pretty well in terms of expecting to get heat just from that.
What about orbital?
Especially for close-in
orbital?
moons. Now,
Orbital
if you
is not
have
gonna
the
change.
problem with Io is incredibly energetic place.
Right.
It's the closest in moon. The problem with it for life is it's so close to Jupiter, and Jupiter is so radioactive, if you will, or well, that's not the right word, but
It makes X-rays.
yeah, X-rays, right? So it's like its radiation environment is horrible, but we could have a large rogue planet where the radiation environment is not so bad, and you can imagine that some inner satellites, they may be small, like Enceladus size or so forth, but you could easily imagine there'd be enough heat for billions of years. Yes, I think so.
Is anyone going to is Drake's equation? Is it just going to stay the way it is, or?
Well, we already know that Drake's equation is an artifact of an earlier age of cosmology, because it's essentially static. He doesn't account for the fact of that the stars have already passed their peak formation in our universe, and it's changing all the time. So there are people who have worked on this, and it's had many tweaks for the Drake equation to try to get it more in line with contemporary cosmology and what we know about star formation and planet.
Does anybody know anything about the population of rogue planets? I mean, I'm sure there's some estimates out there.
Oh, the population of rogue planets is currently thought to be huge. There's the potential that for every solar system that gets created out there, you have possibly an equivalent number of planets who've been cast out. That's a distinct possibility with current models.
So this is going to be one of those weird science.
So then that's like a factor of 10, sort of, right? So 1 order of magnitude.
Well, a factor of 2 anyway. For every planet we know we can find, we can, if we're estimating right now that there's 1 planet around every star, I think that's probably low, but that's the current estimate. And if we say, okay, now it's 2 because we have 1 that is in orbit and 1 that's been cast out. So now we got 2 planets for every star in the galaxy.
Right.
So,
but I guess I'd say a factor of 2 is not a huge deal in this.
It's not a huge deal because
equation.
the big problem with the Drake equation, of course, is that the lifetime of intelligence that's the factor that's just completely bonkers.
So have any of you been following this work by Robin Hansen on grabby aliens?
No.
No, go.
Oh, I'm not really sufficiently expert on it, but it's based on this idea about it's an anthropic principle sort of argument. So the idea is, we have one observation, we're here, and we know roughly when in the history of the universe we are. And the idea is, well, if aliens tend to sort of be expansionary or grabby when they exist, that you can make some, based on relativity and bounding the speed of their expansion, you can make some assumptions about if aliens have the propensity to be grabby, then we would have already seen them. So the fact that, so it implies something about whether aliens are likely to be grabby. And therefore, if you accept that all the UAPs we've been seeing are aliens, that means the ones that we've met must be the non-grabby kinds or something like that. It's a whole chain of reasoning based on this sort of logic. But I recommend Googling grabby aliens. The guy's name is Robin Hansen, Hanson. He's an economist.
I still think there's something wrong with him.
I had an interview with him a few years ago. It's on the well signal somewhere. We talked about that a little bit. The way he's an economist, so he sees economies expanding and growing to hit limits. The ones that you see around by natural selection will be the ones that keep expanding. Find a way to keep expanding. Not so much being grabby because if you look at the resources you have to get, you have to expand. You go to another star system to get resources there, and almost certainly not profitable. There are no one of those aliens in Star Trek. They were always interested in
Ferengi?
The Ferengi, yeah.
Ferengi.
The Ferengi, yeah. Well, yeah. There's no profit. you know, if you have to expend, a petajoule per gram of resource to bring it back to your planet, it makes sense, but so you're not just getting, you have to actually say, my motivation is to go and expand my civilization to that place. And again, extremely costly and risky. So, the question is, do they ever overcome that barrier? That's a huge barrier.
They would have to be pretty desperate aliens, right?
So you're getting back down to the that theory, intelligence implies belligerence. No one know that one?
No.
Intelligence implies belligerence. Is that what you said? Is that what you said? I say yeah.
Yeah, it's from the book. It's a science fiction book called Blind Sight. It's pretty good. It's the argument is that if we ever encountered aliens in our own solar system, the most likely thing would be to assume that they're refugees from a war, because their only reason why anyone would ever go to another solar system is because a problem is so bad in their solar system that it made sense to. Well, the only problem that could be so bad that you'd have to actually leave a solar system is another part of your civilization is trying to kill you. So
that's not viable at all. I mean, look
it's
at
not my book.
I understand. And by the way, it is an excellent book, and there's
I like it a lot.
Ton of great ideas in there. That's just, don't get the idea that that's the only thing in that book. It's amazing. But I mean, did you see the study that David Kipper put out recently? It basically, what can we say using Bayesian analysis about the prospects for life developing on a planet like Earth? And the thing to notice is that life seemed to come up really quick as soon as the Earth cooled down enough. So either it was seeded immediately, possibly from life from Mars, or abiogenesis is just very quick.
Yeah.
On the other hand, intelligence emerged many billions of years later. And even though we talk about the lifespan of the sun being 10 billion years, the reasonable lifespan for the sun to be able to support life on Earth is only about 5 billion years. So if it takes 4 billion years for intelligence to emerge, and 5 billion years is all that life can exist on a given planet, that's pretty slim. You've only got a 20% window there.
Actually, there's been several good papers that have been written that the biosphere is only viable for about another billion years at the outer end, because
surface biosphere.
Yeah, the surface biosphere, but that's where beings like us live. Of course, if we leave the Earth and we create artificial environments, that doesn't necessarily have to limit us. But if you remain surface-dwelling, complex creatures, you're not gonna. You don't have another 5 billion years left.
Oh,
Right,
wasn't
so
that Rock's 5 billion?
I
Rock's was 4.5 billion years until now to get us, and then another billion to go after that, right? So it's consistent with what you said.
Yeah, so the point is, it's not just a war that would make us leave. I mean, it's potential that, when the sun gets too hot, and when we run, eventually in 10 billion years, the sun goes red giant, we could run out of places to live in the solar system. It could certainly happen.
I mean, you could. I mean, I feel bad defending an argument I don't really believe, but I guess the counter argument would be that there's still really no situation. The sun goes up, right? So in who knows how many billion years. It still would probably make more sense to just be out in the outer solar system doing whatever cool science fiction technology with the Jupiter and stuff. Just going to another solar system is what's the nearest one? 3 light years away. So I don't really buy the argument, but I do kind of understood where he was going with it.
Yeah, there's another interesting scenario, and that is if we have completely mechanical life that gets created. Now, I'm not saying that mechanical life gets created from first principles, but if we have mechanical life that gets created and it does become intelligent and so forth, it's been argued that that life may prefer a very cold environment, and they may want to just get away from stars. They may want to be in deep space or in places where they can keep very cold, so they're going to be cozying up to the James Webb Telescope, obviously. So, because cold environment out there. So that's another scenario too, where why don't we see those creatures? Because they don't want to get close to our star at all. So
I still think that it's only a paradox in some, it's not, it shouldn't be a paradox. I just that's my opinion on it. It's because like paradoxes only happen in like binary logic. They really only happen when you create an either or situation and you demand something is in either or the or, and you say, oh, well, it can't be either one or the either or nor. So there's something wrong about the question itself, that there's only two paths. Everything gets destroyed or you inherit the universe. There's something wrong that we're forcing it, that there's only two, this is the only two. And then we're like, well, why don't we see either one of them? I'm like, well, I think that's my only conclusion. I've read all the stuff on it, and that was the only thing I can come up with.
Oh, that's why intuitionist logicians reject the tertium non datur, the no third possibility, and reject the law of the excluded middle in favor of different forms of inference.
All I know is that the word paradox helps sell books, and there have been a lot of books, and that's cool.
Yeah, I mean, I don't know. It's not a great explanation because it doesn't really say, and it doesn't really give you anything you can test with or do anything with. But that was just my gut when I was thinking about it, in the past. Just, okay, we got this question wrong. I don't know exactly what the third or fourth or fifth possibilities are, but the two is creating a paradox, and you never see paradoxes in anything that's got logic above two states. You never see them. It's just they don't exist. So maybe that's the issue.
Well, considering we don't understand 95% of the universe, it's not too surprising. There'd be some big unknowns.
Well, I think the value of paradoxes.
I think the value of paradoxes is not
taken too literally, but they can inspire deeper analysis and actually even ask you where you should be looking. I don't think, for example, if every paradox, I don't really care if it's really a paradox. But I think it has done a lot of good in terms of getting people to think about how civilizations might expand beyond their home world, and could they, and if they did, how would they do it? There's been a lot of analysis about that. It's not all doesn't all reach the same conclusion, but that's the value of it. And there are paradoxes in mathematics. There are paradoxes in logic, and they've all been very good at stimulating sharper, better thinking. Even if whether or not they get resolved or not doesn't matter. People. There's always some famous logical paradoxes.
I think the level of randomness is there. I guess what I'm getting at is the origination of life on Earth, right? Is it all traceable back to a set of determinants, or is there a certain level of randomness? And why is that an important question, in my opinion? Because if you can arrive to a set of factors that have happened for the creation of life on Earth, you can, once you learn those, you can then analyze the probability of the same set of circumstances existing on other exoplanets. But there's a certain element of randomness. Then it becomes much more difficult.
It's the difference between inevitability and contingency.
Yeah.
So if there is an element of randomness, you could have all the boundary conditions for life present, and life still doesn't happen.
Exactly.
Whereas on some other,
Right. So that's what I'm saying. That's why it's difficult if there's some randomness there, it's much more difficult to apply the terms to the equation that would, it's how can you know, right? You cannot really know.
You have
Well-
one data point, right? So you know.
If I were to,
Well,
Like-
if I were on,
if I
Right,
knew
but we
if-
don't. That gets
if I knew
of course,
if-
to the,
It's not just how it's not just
it's,
random.
it's not just how it's not just random. It's how random, right?
If you
I mean,
have
If you have
if
the alien scientist comes down and tells you the probability that life would have started on your planet given the conditions was about 80%.
would you consider that randomness?
Would you consider that randomness, or
Yeah, then you conclude it happens all the time,
well, not all
right?
the time, but
Because
well,
80%.
not all the
4
time,
out of
but
every 5 times it would happen.
4 out of every 5 times it would happen.
So
No, but
Right.
Well, you,
So,
you would
uh,
also
Four out of five times when the
conclude.
initial conditions are present, because the numbers are so big. That means it's guaranteed to happen
Oh, yeah, it's happened all
many
over the-
times.
Oh
all
yeah,
the
it's happened all over
galaxies,
the
right?
the galaxy,
there
sure.
are
Yeah.
people right now who are
Well, there
working
are
You
people
would
right
also
now who are
conclude that
working
it happens
on.
much more rapidly where there's an 80% chance, where if there's a 10% chance, you might have to wait 100 million, a billion, more years in
100
order
million
for it
years is
to
a
happen.
blink of an
100
eye.
million
Well, so
years
this
is a
is
blink
why
of an eye. and
I
that-
like Hansen's model. He likes to think about this explicitly in terms of like hard steps, how many hard steps there are, right? And maybe each
Yeah.
you sort of have some crude way of translating the number of hard steps. Like if you basically, the point is you don't necessarily want to think about it as a Poisson process. It's like it's the rate at which it happens is some fixed number over time, starting at whenever the planet cools down and going on forever constantly. But like there's these plateaus of we don't really understand it, so we
But
don't know what the
there's
hard steps
there's
are.
always
He uses
there's
a
also an
Poisson distribution
anthropogenic
function for
bias,
that?
though, right? There's also an anthropogenic bias. In other words, are we also looking at are we not also considering the possibility that there's other sets of conditions that possibly could generate other forms of intelligent life, unlike the ones that have emerged on Earth?
Mhm.
So in that case, it could be you could put another element of uncertainty there, right? Because there's been discussions about non-carbon based life forms, right? Could there be an intelligent non-carbon based life form? Is it possible? And if that's the case, there could be other initial conditions. Right.
Other boundary conditions, and then
Yeah.
other measures of contingency. And you might
Yeah.
have one planet with an 80% chance of silicon-based life and a 20% chance of carbon-based life.
Right. Yeah. So at that point, when you talk about habitability, right? We're talking about habitability in anthropomorphic terms, right? Always. We're talking about what's habitable. What would be habitable to a life form known to us? We don't talk about an habitable zone for a non-carbon based life form, right?
I
Correct
think
me
the
if I'm wrong.
astrobiologists like to think that they're not being completely anthropically biased.
Well, it's changing. People are trying to define conditions for, and especially through the work of synthetic biology, being able to make things that weren't made in nature, you start to get more of a sense of what the possibilities are.
Right. But what I'm talking about, the classic habitable zone, the Goldilocks zone, right? When we're talking about that, we're talking about, to the best of my knowledge, we're talking about
water.
based
right?
on exactly based on conditions that have
There's
facilitated the life to emerge on Earth. So that's a
Well,
pretty,
I don't know. I mean, I think it's a hypothesis, right? That
if you're gonna hook this back to the Fermi paradox, though, you have to talk about the emergence of technology. We've had lots of intelligent species on this planet, some
I know I
going
saw an
back
article about that.
many billion years, but they're underwater and they never developed technology. So what about these
you speak
worlds?
of the
that-
Atlanteans, of course.
Right. So what about these water worlds we're talking about, Europa and moons like that, which may be a predominant place for life to form? Can any of them ever expect to get to the point where they have technology if there's
But
no
that
land?
becomes-
There's,
That
it's
becomes
hard to say.
another anthropocentric exercise, because it seems impossible for us to have a technological civilization underwater. But having talked to many people about this, there's all kinds of ideas out there for technologies that could be created in an underwater atmosphere.
But there's one
Right,
big
but the
problem with
experiment on Earth is that it hasn't happened, despite having creatures that are extremely intelligent.
But at some point, it's like a
but
physics.
there's
and
one
chemistry
big
thing,
problem
right?
with a water civilization.
Go ahead, Isiah.
Go ahead.
Well, it is, because the problem with water is that it conducts heat very, 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 very well. So building up any kind of metal production in water is really, really hard. I mean, we pay, if you want to be an underwater welder, you can make more than most doctors make. It's extremely hard, extremely hazardous. So it would be really hard to imagine technology civilization that lived in water. I don't think it's
But if you read
anthropomorphically
Andy Weir's
biased.
most recent novel, right? They have an ammonia atmosphere and they use xenonite as instead of metal, right? You have you guys? It's pretty far fetched.
Yeah, I don't know. I think, still air doesn't conduct heat almost at all. It's one of those perfect insulators, but still water does. That's a really, really big difference to me. In terms of
And that is an
heat.
argument. That is an argument that has been made. I think Dyson was the one who said that bees were too small to control fire, and you couldn't have a metallurgical technology underwater. So that puts certain parameters in place for a technology. But I think we have to certainly, the kind of technology we have would not work underwater. The question is whether there are alternative technologies, as there could be alternative biologies that don't use metallurgy or don't use control of fire.
It's hard to imagine. How do you generate electricity?
I think there could be technologies like that.
I think there could be
anything's
technologies
possible.
like that, but are they civilizations we could ever hope to make contact with?
And would they ever have a chance of
leaving the water and going out into their atmosphere and into space?
How would you build a rocket in water?
How do you?
It's amazing.
How do you master electromagnetism in water?
Maybe it's possible.
Maybe it's possible, but I have no idea.
And even if you do have land and so forth, and creatures can live on it, how do you know there are enough resources available? I mean, if you could be in a very old star, old planet where there's just not enough heavy metals to really support what we've been able to do here on the Earth. So
I think the technology question is too hard, basically. But the habitable zone question that Ciro brought up initially seems like it's tractable, because if you define the habitable zone in terms of liquid water as opposed to say liquid methane, right?
Well,
and you say, is that too anthropocentric? Hard to say, but I feel like chemists should be able to answer that question.
We do that because we do that.
We just have to be very careful that there's two different questions, and one is the amount of life in the galaxy or in the universe, and the other is an amount of technological emergences that could theoretically be communicated with. And those are just two very, very different analyses. That's all.
That's true. That is true.
Point.
But if we look just at the let's look at life in general, okay, from the cellular form, and then we can go to intelligent life. There's a paper of 2014, as a matter of fact, I just found it because I was very curious about this question, that explores the possibility of the existence of life on exoplanets that do not have any water at all.
I found I saw this article a few years back, put it up in the chat, by the way, alternative hypothetical types of biochemistry. Exactly. It's a really good article.
Yeah, exactly. And there was a study done, and that looks at the possibility of the existence of life on environments where there's no water, no liquid water whatsoever. And if you consider the possibility that there might be the emergence of life on exoplanets that do not have any water at all, then you open up you blow up the entire thing, because when we look at normally when we look at the habitability, we look at life much based on the existence of water. We don't even barely, if ever, consider why, because this is what we know. This is by the biochemistry that we are.
I thought it was grounded in some reasons. I thought the reason would be something like, well, whatever your definition is, it has to involve some sort of self-repeating chemical reactions. And
so we need a solvent, right? That's
right.
the idea.
So some solvent,
Right.
And there's physical reasons why water is the most likely one, but I don't necessarily know the relevant background there, right?
But the chemical reasons that we are aware of, right? I understand that they are studied and that they are proven, but they're still, how can I put it?
But the laws of physics are
anthropomorphic
the same everywhere, right? So
they're still known to us because here we are, and this is what we know. And these are the elements. I know the universe, all the elements in the universe are all the same and everything. Hydrogen, helium, etc. But there's always a possibility that there's some sort of something that could have happened in another environment.
But like we can put constraints on it. Is the point I'm trying to make. I mean, like we know there's no life is based on liquid ununoctium or some super radioactive element with a half-life of microseconds, probably, right? Because there's just no way it could last long enough, right? So
are constrained maybe too constrained? Some of them. Not all of them, but some of them might be too constrained.
So
you just have to be explicit about your.
You just have to be explicit about your assumptions. That's all.
We only know of life in water.
We only know of life in water, but
a lot of people are looking seriously
into the possibility of life on Titan, where liquid water would not be a factor.
If it's water,
it's hard frozen ice.
Right. So that's the methane case, right?
Yeah.
Methane and other.
Isn't the NASA slogan
and other?
Isn't the NASA slogan "Follow the water"?
On Mars,
and that's why
on Mars it is.
On Mars it is. Yes.
But only for Mars. Yeah.
But only for Mars.
So,
So
in terms
not
of
for Titan.
in terms of the institutions, like NASA and academic astrobiology, it's definitely this is the main program, but it doesn't exclude other programs.
Which makes sense.
Yeah, well, they're excited about.
We don't spend the money on something.
Enceladus and.
Yeah. I mean, we look at Occam Razor, right? I mean, we're not going to go ahead and we don't want to spend the money at a more exotic explanation on things, or exotic possibilities, I should say.
Well,
but that doesn't mean that if you look at something like a Drake equation, which is what we were talking about to begin with, my point is we should be much more open-minded about what terms are going to that equation. That's why it makes it so difficult.
It was never meant. It's a cannonball.
Right?
Don't polish the cannonball,
it's not
right?
Meant to be,
it's not meant to be.
Give you a precise answer,
Just to give you round numbers,
and
ask you what factors are most important. And I think
it was originally called the container for ignorance.
Yeah,
when we
started out with the 7 factors, we knew one of them reasonably well. Now we know 3 reasonably well.
Working on the 4th.
And we're working on the 4th. The 7th one, though, is the killer. We have no idea how long technological civilizations persist. If they only live for 100 years or 200 years, we'll never find anybody out there. If it's
it's probably
one of the things.
It's probably a bimodal.
My sense of it is that there's
my sense of it is that there's probably
it is like 100 or 200
it is
years
like 100 or 200 years
nearly all, but it's a
for
fat tail.
Nearly all, but it's a fat tail.
It's
going to go out. You're going to get some that live for a lot longer. But the Drake equation only looks at averages.
If you're looking at
it's
averages,
going to it's not going to be very many. But you might have one out there somewhere. Because they found a way to survive for 1 million years.
Right.
So, Paul, what about using, instead of bimodal on all the different civilizations, why not use it on one? We still have the Amish riding around their buggies, right? Why not assume that, okay, maybe the bulk of the civilization doesn't last that long, but maybe some part just keeps on going and going and going.
Well, that's a problem with averages. You can have averages get skewed horribly by outliers. So that's why people like Machoni have proposed things like this stochastic Drake equation, which is more sophisticated. But the problem is the Drake equation was never meant to be a way of calculating the number of civilizations in the galaxy that we could talk to. It was meant to give us an average round number
How
for
sensitive our radio telescopes
how sensitive our radio
to
telescopes
hope
need to
to have any
be
hope of
to
detecting one.
hope to have any hope of detecting one.
And
Actually,
And-
it was less ambitious than that. It was simply something that Drake cooked up the day before the first conference to talk about what evolved into SETI. And there was like 10 people there, and they had no agenda for this meeting. And he cooked up this equation just so they'd have something to talk about for this one meeting.
what I think,
That's where it came from.
What I think
its value is that
its value is that it divides the problem up into
some pretty
reasonable partitions.
Asking questions of
astronomy,
and then sociology,
biology, and then sociology.
and the last
and
one,
the last one, and
or maybe the last two,
or maybe the last two.
The sixth one is,
which the sixth one is
you've got life.
okay. You've got life.
Is
Is it going to evolve into something that makes technology?
Technology that we can detect.
Technology that we can detect.
Hey, hey, Paul, let me make
So-
one quick point about Titan real quick, since that's kind of a bugaboo for me, because Titan actually has two different possible scenarios for life developing. One, near the surface where we have the extremely cold but interesting, really weather using very different chemistry. But also, deep underground in Titan, there is potential for liquid water ocean, just as you have on Enceladus and so forth. So if we should discover life on Titan, which would probably be nearer to the surface, we still cannot preclude the possibility that abiogenesis requires water.
Okay.
But I
We
mean,
have to strip,
very
strip mine
that
the
would
place.
take a lot of study
That would take a lot of study
to
figure out how where the
If the
abiogenesis
chemistry
came
is
from.
something
If the chemistry is something that
is totally incompatible with
is
water,
totally
then that would
incompatible
be-
with water, then that would be
that would pretty much
No,
That
there
would
are
pretty
life
much
forms
say-
on Earth that are very. Yeah, I would say there are life forms on Earth that are not compatible with water.
Arsenic on, are you thinking on monolake, perhaps? The arsenic?
And then there's also
that
some
one got
very deep
discredited.
underground.
that one got
um,
discredited.
There's some very deep underground organisms that basically live off of radiation.
Yeah, but
So
we
I don't, you know,
we
it
don't
is-
we don't think that
they
they're
lack a common ancestor.
that they lack a
with us.
common ancestor with us.
No, I don't think that. I think you're correct. Yes, I just think that if you come across a species on some other planet that does not require water, you still
Well, no, it's
have
not required
to
water.
ask
Well,
the
no, it's not
question.
required water.
biochemistry would
It's
have
the
to be
biochemistry would have to be completely
incompatible with water.
incompatible with water.
I mean,
I mean,
and that would
Down,
be
and that would be
very difficult to prove.
very
but,
difficult to prove. But
I think that would.
I think
could
that
make
would.
that case
Why
You
do-
could
enough
make that
study.
case.
Why
with
not
enough study.
requiring? Why not
I-
requiring water means? I'm asking Paul, and I'm honestly asking. Why not requiring water would imply complete incompatibility with water?
I'm not. No,
No.
I'm not saying that.
I'm
does.
not. No, I'm not saying it does.
It's a different
Oh,
story.
okay. I'll,
It's a
I'll-
different story.
One example of incompatibility of water is the Wicked Witch of the West, because when Dorothy threw a bucket of water on her, she just went up in smoke.
Well, there's your
So
proof.
that's the kind
There's your
of
proof.
you could call that the strong condition, where it actually kills the organism if it's exposed to water.
It
And the
melts.
weak condition
It
would
melts.
be, well, yeah, I'm melting.
So
And the
it'd
weak
be,
kid-
What about evolution? What about evolution and adaptation, Nick? Like, what about the organism that maybe form in a certain medium and then evolve to live in other environments?
Well,
Like,
sure,
for
that happens all the
instance,
time on Earth.
Well, sure, that happens all the time on Earth.
That's happened.
right? Exactly.
Countless
That's
times.
happened
But
countless
that's not
times.
the same thing.
But
as
that's
having
not
a
the same
radically
thing
different
as having a
biochemistry.
radically different biochemistry.
Right.
Basically, everything on
Basically,
Earth that we know
everything on Earth that we know of
based on the same
is based on the
essential
same
reproductive
essential reproductive
chemistry.
chemistry.
Absolutely.
It's
there-
entirely possible. That there's
It's
something
entirely
else out
possible
there,
that there's something else out
even
there,
on our own planet.
but even on our own planet. But
In detail, it's a little more complicated than that, because if you read the recent papers on the origins of archaea bacteria and eukaryotic cells. This is the three kingdoms model that we get from Carl Woese. There are serious, not crackpot, but there are serious papers that have been proposed that there are distinct origins for these. And so if archaea have distinct origins from bacteria or eukaryotes, or on the other hand, bacteria have distinct origins from archaea and eukaryotes, but they've meshed over time within the biosphere, at least on an ecological level, if not on a biochemical level. There could still be multiple scenarios on Earth of multiple emergence of life forms that subsequently, like viruses, that subsequently became integrated. First,
viruses aren't even considered life, right?
I know.
Well, that's another thing, and that's
I'll
another
count them,
topic
right? I
in
mean-
biology that there's disagreement on whether viruses are alive or not.
But they're
I
also
mean-
not that fundamentally different, right? I mean, they
still
use
it's still
RNA instead of
replies-
DNA.
It still relies on
DNA
everything
for
relies on DNA for replication.
Right, and there's some
those
Makes
are
them
RNA
no,
viruses,
because
proteins
but-
work by manipulating these lipid bilayers that separate insides from outsides, right? And that's totally water based.
Yeah.
And
the non-eukaryotic life on Earth that's primarily sustained by horizontal gene transfer does not reproduce itself by DNA splitting and copying itself. So there's an ongoing
I would dispute that.
I've seen
there's an ongoing
I've seen-
controversy as to whether these things can continue on their own, and the extent to which they're independent from each other or not independent. But when you get down into the cells that don't have a nucleus, what used to be called prokaryotes, but now they're divided into bacteria and archaea, they're quite different.
So multiple origins, and
Well, there are-
possibly viruses could have been some other origin as well. That what I'm saying, or
since viruses
Since viruses rely on other
on
organisms to
propagate themselves,
they could not have originated independently.
That's the logic that I understand.
That's the logic that I understand, as I understand it.
yeah,
That they
They are
basically
basically
exploit
chemical machines that exploit
existing chemical machinery
existing chemical
to make more
machinery
copies of themselves.
to make more copies of themselves.
Over
Which is on the
billions of years,
entire
they've gotten
world.
more
Over billions of years, they've gotten more
sophisticated.
sophisticated and more sophisticated,
And some of them may even be beneficial.
and some of them may even be beneficial.
Nick, if you have a link about the thing you were talking about, I'd be interested to read it.
Well, I just finished listening to The Tangled Tree, A Radical New History of Life by David Quammen. So it's a very
discussed in there.
good treatment of recent microbiology, especially. It focuses on the life of Carl Woese, who was the one who created molecular phylogeny and discovered the archaea, but it also treats almost all of his main rivals and collaborators. So it's a very detailed history of molecular phylogeny in the late 20th and early 21st century.
I placed the link. Amazon.
Thanks, Ciro.
Yeah, I saw that.
Yeah, I saw that.
Well, I mean,
Well, I mean,
okay. It's
okay.
11:30.
It's 11:30.
Yeah, I'm gonna sign off too. I think.
I've enjoyed this
Out
very
of bounds.
much.
I've enjoyed this very much.
I don't have to be.
Well, I don't have to be.
I am totally alone
Actually,
in the house
I am
this
totally
weekend.
alone in the house this weekend.
Everybody else is somewhere else.
Everybody else is somewhere else.
You've been abandoned.
No, I'm not complaining.
No, I'm not complaining.
They wanted to clear out so you could have a big party while everybody was gone.
Yeah, that was why.
Yeah, that was why.
No,
No,
daughter's up to visit
And
her
you're
boy-
working on getting
daughter's
some
up
big.
to visit her boy.
Yeah, my daughter's
Yeah.
up to visit her boyfriend.
My daughter's up to visit her boyfriend, and my son and
Ohio.
wife are in Ohio,
And so
and so
it's just me and the dogs, the cats.
it's just me and the dogs and the cats.
Paul, did I see on the Discord that you're working on getting some big name guests for the podcast? Or
I am working on that. Yes,
I am working on that. Yes,
And, although I
And although I need to hear back from Beatrice
if she's had any luck.
if
So,
she's had any luck. So
and I think she's like everybody else in Europe right now.
like everybody else in Europe right now. She's
off enjoying her holiday. But,
off enjoying her holiday, but
It's August. Yeah.
So there was just a tweet today by the Green Bank Observatory. They're itching to get onto some podcasts. So
yeah, I saw
might
that.
want to make
I'm
a
not
note.
su-
yeah, I saw that. I have had
Andrew
Andrew Simeon on the podcast
a couple times.
before, a couple times.
He does work at Green Bank, although
He does
he's
work
with
at Green
Berkeley.
Bank, although he's with Berkeley
Breakthrough Listen.
and Breakthrough Listen.
Yeah, well, we'll see. I would love to
Yeah,
do
well,
a
we'll see.
live
I would love to do a live
with a small panel
and
a distinguished guest.
a
And
distinguished guest.
one thing I had in mind was
one thing I had in mind was
we would do the ethics of Medi.
we would do the ethics of Medi
because we had Chelsea Jaramillo on.
because we had Chelsea Jaramillo on last year.
She's a philosopher who talks about
She's a philosopher who talks about things like that. And
The one on existential risk. Was that the one?
on what? No, it was
On
on.
what?
It was on the ethics.
no,
of
it was
Medi.
on,
she
it was
had-
on the ethics of Medi.
She had some kind of thing that was said he was was almost risk free, but Medi was obviously not.
Yeah,
I kind of remember.
Yeah,
I'm not sure I understood her
I'm not sure I understood her
taxonomy on risk there. but,
taxonomy on risk
anyway,
there, but
anyway,
we talked about it, and
there's many things I don't understand. So
there's many
it's
things
okay.
I don't understand,
But,
so it's okay.
The,
But
I thought, well, wouldn't it be cool?
I thought,
to
well,
get
wouldn't it
her
be cool
and
to get her
Greg
and
Vaco, she's like a big
Greg
Medi
Vaco, she's
cheerleader,
like a big Medi cheerleader,
and
and
maybe some other people
maybe some other people
to talk, just
to talk,
beat
just
it around a
to
little bit.
beat it
Do
around a
that
little
live.
bit, and do that live.
And I've meant to do
Uh,
that,
And I've meant to do that,
but I have life has
but
been
I have
difficult
life has
lately,
been
and I haven't really
difficult
had much time
lately,
for
and I haven't really had
podcasting,
much
much
time for
energy
podcast or much energy for
So-
podcasting.
It'd
So
be fun if they could be put in the same room and we could make it a cage fight.
Yeah, like Nerf Bash or something.
well, yeah.
I was thinking more like
well, yeah,
Thunderdome.
you know,
Chelsea's quite a bit younger.
Chelsea's
than,
quite a bit younger than
Vaco. She might have a chance.
She might have a chance.
Well, yeah, and of course,
Well, and of course,
more like Hunger Games. I was
more like Hunger Games. I was thinking.
thinking. Let 'em have weapons.
What
Yeah,
about
I think
weapons?
debate is a good format that hasn't been explored too much for this subject area.
Well,
So.
yeah, and
Well,
I'm not.
yeah,
a good
and
moderator,
I'm not
so
a good debate moderator,
I may
so
look to somebody else to do that.
I may look to somebody else to do that. But
You want to get the guy from Monk Debates or Intelligence Squared or some big famous debate moderator.
Yeah, well,
We go on.
I'm open to suggestions.
I'm open
The
to
guy I had in mind
suggestions.
was
The
actually
guy I had
David
in mind was actually David Grinspoon, but
I don't know if he'd be that good a debate
I don't know if he'd be
moderator.
that
Well-
good a debate moderator.
If we get David Grinspoon, there are a whole bunch of other things I would want to do with him that other than talk about Medi.
I've had him on
He's-
3
he's-
times.
you know,
I've
he's
had
the
him on
guy-
3
he's the-
times on the podcast.
I know, and he's a fantastic guest. You
Yeah,
should
I
have him
didn't
on
tell
every
you all.
chance he's gonna do it.
I didn't tell you guys that I was on a panel a few weeks ago. I was invited by Dr. Pamela Gay. I don't know if you know.
Yeah.
you all
Oh,
know.
nice.
Yeah.
Yeah, I was
yeah.
on a panel with. They did CosmoQuest. What is it called? That, well, the marathon, but they use a different name, anyway, a fancy name. Anyway, the point is that they had a lot of. There was a nice format. They had the Discord and Twitch and Zoom used, and a lot of different panels for the entire weekends. To raise money, obviously, but. It was interesting. There was Dr. Greenspoon, of course, and a bunch of other, some rather interesting names. And subject matter was completely, different areas.
I just
Yeah.
really want to. I want to.
You gotta
I just really
balance.
want to. I want some
Thanks a
people
lot.
to argue about
Yeah, good
shows
stuff.
and
about
should nots of
the
Medi.
shows and should nots of Medi.
Because I think
Um,
Medi is.
you
Because
know,
I think Medi is.
Sorry again.
Sorry again.
I'm sorry, I didn't mean to change subject. I was thinking about, you said you were going to go ahead and have a interview with Daniela, if I'm not
Oh,
mistaken.
Danielle is coming up
About-
soon.
Oh,
yeah.
Danielle is coming up soon.
About her
Yeah.
new project.
About her new project.
She's she's been busy.
She's been busy.
And I think she may still be
And
doing
I think
some
she may still be doing
stuff with
some
Cogito,
stuff with
which is,
Cogito,
beaming brainwaves
which is
into space.
beaming brainwaves
But that
into
may be
space. But that
kind
may
of
be
fading now. And I think
kind of
she's got a
fading
new
now. And I
project.
think she's got a new project.
She's got other stuff.
Nice.
She's got other stuff going on.
She did the whole moon. We did
She
the
did the moon.
moon bounce thing,
We did the whole
couple
moon
years
bounce
ago.
thing a couple of years ago,
which was
Right.
which was.
I tried my best to
I
facilitate.
tried my best to facilitate it.
The audio quality coming
The
from
audio
Scotland
quality
was
coming
terrible.
from Scotland
But,
was terrible, but
On
did
the
our best.
island over there, right?
did our
On the
best.
island of
Yeah.
Scotland.
yeah,
It was kind of cool.
yeah,
Yeah, but we
yeah. But
you can see the images anyway.
you can see the images anyway.
People were, it's
that
an
people
art
were-
project.
It's an art project.
You know,
It's not.
if people are looking for
You know,
sciencey
if
stuff,
people are looking for sciencey stuff,
Science-y,
it's
but it's not
science-y, but it's not
It's an art
science. It's an
I
art
enjoyed
project.
it.
I enjoyed it.
It's a little art too there.
Yeah.
Danielle wants to get people engaged.
Danielle
with
wants
these
to get
things
people engaged with
in-
these
in
things
creative,
in
fun
creative,
ways.
interesting,
And she's
fun
doing a good
ways,
job.
and she's doing a good
it's not-
job.
you know,
And
she has
it's not
to
you know,
really
she has
scramble
to really
get
scramble to
funding for
you know
all
to
this
get
stuff. So
funding for all this stuff. So
Very much.
she's done a good job.
she's
And
done a
the
good
new
job.
project, I don't
And
know much
the
about
new
yet, but
project
I'm
I
gonna
don't know much about yet,
ask her
but I'm
about it,
gonna
have her tell us about it.
ask her about it,
and
have her
that'll
tell
come
us
soon.
about it, and that'll come soon.
And
And
we're also probably going to have.
we're also
some other
probably
people
going to
on,
have some other people on.
But like I said,
Like I said,
energy level.
my
and
energy level and my
for podcasting
has been
It's
low.
not my. It's
And
it
it's
is
not
my
my
fault,
it
but
is my
not
fault, but it's not my fault.
Well, if you want to do panel, I mean,
Uh,
they may relieve you. I mean, obviously, you are still the technical coordinator and everything, right? But if you want to go ahead and do like a panel of a more selective, right, panel, not like casual, but where we know the subject matter ahead of time, it might relieve you a little bit of the stress of being the sole interviewer, I guess.
Well, I
But
mean, what I
you
want to do
should-
is
Well,
get
I
some
mean,
people
what I want to
talking
do is get just people
about
talking
these
about
really.
Right.
these
thing-
really.
It comes to ethics
thing-
committee. This is
it comes to
something
ethics
where
committee.
I
This
do
is something
not
where I
have
do not have
a clear point
a
of view.
clear
I
point of view.
I
I
see
see
the
the
ProMedi
point of the
and I see
ProMedi,
the-
and I see
what
the
some people are saying.
what some people
we
are
should be more
saying
cautious.
we should
Or
be more
people like Jill
cautious,
Tarter who
or
say
people like Jill
something
Tarter who
"We're
say
just not ready
something
to
like
do that."
we're just not ready to do that.
Or David Grinspoon, who I
Or
think
David
I just
Grinspoon,
finished
who
reading.
I think
Yeah,
take-
I just finished reading a book that devoted a fair amount of pages to this question, and his point was that our focus on METI is going to change to the degree that SETI is successful. And that's a very interesting viewpoint. It's like, it's not so much should we do METI, it's like in what circumstances is it acceptable to do METI? And if you couch it that way, you can actually have a fruitful discussion
well,
and
What's
not
the
just
book?
make it a black
Well-
and white thing.
well, classic
Yeah,
SETI,
I
classic
think it-
SETI, though.
SETI.
I think it was called
Classic
something
SETI,
like
though.
the case for contact or something.
Think of the classic SETI.
You
Now,
think of
now,
the classic
there's a
SETI.
new
Now,
thing
now,
called
now
techno
there's a new
signatures,
thing called
which
techno
is
signatures, which
broader
is
than this.
broader
But the
than
classic
this.
SETI
But the
had
classic
assumed
SETI
that
had
somebody else
assumed
would be doing METI,
that somebody else would be doing METI.
that we'd be
that
the
we'd be
recipients
the
of a METI campaign.
recipients of a METI campaign
Because
uh,
our receivers
because
weren't
our
sensitive
our
enough
receivers weren't sensitive
detect-
enough
to
to eavesdrop,
and
and
they still aren't.
they
Even
still
with SKA
aren't even with SKA
at full
at
sensitivity,
full
it's just
sensitivity.
barely enough to
It's just
eavesdrop
barely
if
enough
you're
to
lucky,
eavesdrop
right?
if you're lucky,
So,
right? So
SETI
you know,
really.
SETI
now, tech-
really
the search for techno
now
signatures
the search for
broader
techno
than that.
signatures
It
is broader than that.
actually
It
be
may
able to
actually
find ways
be
to
able to
detect things that
you may find ways to
are
detect
not
things
intended
that
for us to
are not
receive.
intended for us to receive. But
Jason Wright's done some work on
and
that.
Jason Wright's done some work on that. Other people, but
In fact, Jason Wright
in fact, Jason Wright may be my best moderator. I have to think about that. But the
the notion is that if nobody's
the notion is that if nobody's willing to do METI, then
nobody, at least with
nobody,
our level
at
of
least with
technology, can do SETI.
our level of technology, can do SETI. And
So you know, this
so
whole question of
you
the
know,
risk
this whole
is
question of the
a
risk
complicated one.
is a complicated one.
I personally, my own.
I personally,
opinion
my
is,
own
so far,
opinion is,
and
so
not
far,
having seen much more analysis,
and not having seen much
than
more
that,
analysis
is the risks
than
are
that,
very low.
is the risks are very low. But
They may be.
they may be they may be
on the order of
very low, but the
consequences could be very high.
consequences could be very high.
Well, here again is one of those calculations that is not easy to make because there's way too many unpredictables, obviously, to be able to understand exactly what kind of risk level. I mean, it's really not. I don't think it's knowable.
Well, you can.
That's why with
Well,
the term, white swan or black swan event has been introduced to cover those risks that are low likelihood, high impact.
Right, but the likelihood itself, it's unknown, isn't it?
Yeah, you can't calculate it because there's not enough information to calculate it.
Well, that's true.
Well,
but,
that's true, but
you can maybe bound it,
you can maybe bound it,
or you can make arguments,
of
what would be
how would
an agent some other agency
regard the cost benefits of hostility
us,
towards us,
from the distant star
system.
Risk reward. It's all risk reward, right? What's reward of the risk?
Maybe they just hate us.
Maybe they just hate us, right? Maybe they just want to kill us.
Well, the reward is we get access to the Encyclopedia Galactica and all the knowledge in the universe.
Right.
The risk is that we get exterminated or worse.
Yeah, exactly.
And worse than extermination would be subjecting the human population to horrible suffering and torment for an undeterminate period of time.
Unlike usual.
Sure, yeah.
Unlike usual.
Unlike usual. A more advanced civilization would be able to cause much more human suffering than even human beings can cause if we wanted to.
If we want them to make us.
So if you're coming at in recent existential risk theory, people have introduced what they call S risks, which are risks of astronomical suffering. I'm actually going to give a talk about this tomorrow to a bunch of analog astronauts.
X risks,
and some people
Tuesday?
S as in suffering. S
S.
risks. X risks are
S.
existential risks. S risks are risks of astronomical suffering beyond anything we've encountered so far in terrestrial history. And the people who are writing papers about S risk, they argue that astronomical quantities of suffering are worse than extermination. So if you're actually faced with the prospect of an S risk, you would be better off committing suicide or committing, a species scale suicide than enduring the S risk of astronomical amounts of suffering.
Interesting. Yes.
Well,
They can make you immortal. They make you immortal and make you suffer forever.
Exactly. That would be one of the risks. Exactly.
Well, that sounds like some religions I've heard of.
It sounds just like hell.
Yes, that's what it would be. It would be a
lake of fire.
A simulation of hell.
Apparently, we already have that risk. So there you go.
A sufficiently advanced technology could create a perfect simulation of hell. And that would be if you put all the human beings in that would be a very bad thing. That would be an S risk.
As a regular blasphemer, I consider that to be unlikely.
It could be an experiment to them. They could be completely unethical, completely emotionless, and they were just an experiment, and they won't experiment on the what's the suffering, eternal suffering, going to do to these creatures.
Right. Exactly. Yeah. Or they might enjoy inflicting suffering.
Joy, yeah.
There are people who enjoy.
Let me get back to one point relative to the SETI thing. And Paul made a statement that, well, what if nobody's doing METI? But there are some scenarios where METI starts to look real good. Like if your sun's going to explode soon and you're not going to survive it, right, you might want to do METI or something like that just to be able to say to the universe, hey, we were here. So you're just basically putting up.
I know a guy who thinks that's happened.
I know a Scottish.
I know a Scottish astronomer
that's actually happened.
Who thinks that's actually happened.
Okay, so that's interesting. So, but the question in my mind when I hear that is, how close is iRace to being at that point? I think we're pretty close. And so doing METI just as a way of saying to the universe, we were here
Help!
has some merit in my mind.
I'll take it one step further. Rock, what if it's an SOS?
Exactly.
I mean, it could be a message of, we used to be here and we don't have anything to lose at this point,
Or
so
our sun will
we're just
blow
going to
up.
beam
Or
the
our sun
message.
will blow up.
Or it could be,
a million
yeah, or it
years.
could be,
Exactly.
save us.
Exactly. But how
Save
close are we
us.
are to that point where we should be sending out SOSs in the
Now,
hopes of getting a hold of this Galactica encyclopedia so we could maybe save ourselves.
right.
I think we're pretty close. I mean, that would be the argument for Maddie for me.
Yeah. Definitely.
Basically, let's send out the distress signals now while we can.
Well,
Right.
Well,
Too late.
I don't think that's
I
entirely irrational.
don't think that's entirely
The guy
irrational.
referring to was,
The guy referring to was
he makes connections that I don't
he makes connections that I
agree
don't
with, but
agree with, but
he connects the long delay
he connects the
echoes
long delay
to
echoes
a dying
to
civilization.
a dying
yes.
civilization.
Interesting.
His name is Duncan
His name,
Lunan, and
his name is Duncan Lunan, and he believes that
the long delay echoes
the long delay echoes came from a civilization that
is
from
Epsilon
Epsilon
Boötes,
Boötes, and that's a red giant star, which is
if they're there, they don't have very long.
if they're there, they don't have very long.
Interesting. Hey guys, I got to run. It's been fun though.
Okay,
I got about
I
you.
think we'll wrap
Okay,
it
well,
up. Thanks,
I think
everybody.
we'll wrap it up. Thanks, everybody.
Thanks, Paul.
All right.
Good to see you. Good to see you, Nick. Good to see you, Rock.
Yep. Good to see you again.
Okay,
Have a
Do
good
it
night.
again in 2 or 3 months.
do it again in 2 or 3 months. All right.
Bye.
Bye.
Good night, everybody.